So let us start. Could you please confirm that are able to hear me? Simply type if you are able to hear me. Could you please confirm that? Yes. Right, friends. Okay. So in tree concept, mostly you can focus on some areas where the first topic is properties of trees. Like we'll discuss binary tree, binary search tree, AVL tree. Okay. So each and every tree we have several properties. We need to recall all those properties. After properties of trees, next we want to discuss a tree traversals. Tree traversals like in-order traversal, pre-order traversal, post-order traversal, right? Afterwards, we have to construct a unique binary tree by using in-order and pre-order, in-order and post-order, right? So after tree traversals over, next we are going to discuss another topic is called binary search tree. Afterwards, AVL tree. AVL tree. So fifth topic, like we going to discuss time complexities based on various operations. Like inserting a node into AVL tree, how much time compressor will take? Deletion of node from AVL tree, how much time compressor will take? What is the time compressor construction of AVL tree by using n elements? So all these time compressors will be covered here. Okay. So that's all. These are 4 different topics where they are frequently asking in trees concept. So first we'll start with the properties of trees. By taking questions, I'll explain properties of trees, friends. Okay. So by taking questions, I'll explain. So when we are talking about properties of tree, we need to recall the symbols also. Like for example, if n indicates total number of nodes, n indicates total number of nodes, and I indicates number of internal nodes, number of internal nodes, H indicates height of the tree, where L indicates number of leaf nodes. Then we want to discuss properties of various types of trees based on these parameters. Okay. So when you are talking about various trees, the first one, suppose if I ask total number of nodes in a binary tree, the total number of nodes in a binary tree depends on the structure of the binary tree. Depends on the structure of the binary tree. Therefore, if the tree is skewed binary tree, or if the tree is full binary tree, or tree may be having structure like this. Okay. If you observe all these trees and every tree is having height is equals to 2, height equals to 2. Height means longest path from root to leaf node is called height. So height of the tree is equals to 2 here, height of the tree also 2, and that height of the tree also 2 only. In this case, how many number of nodes are possible in first example? In first example, number of nodes n is equals to 3 are possible. Number of nodes n is equal to 3, whereas in this case number of nodes n is equals to 7, where here number of nodes n is equals to 5, right? But height of the tree remains same, that is for h is equals to 2, for height h is equals to 2. So whenever height h is equal to 2, minimum here 3 nodes are possible and maximum 7 nodes are possible, or it may be oscillating between minimum and maximum. So minimum is possible if it is skewed binary tree and maximum is possible if it is a full binary tree. Then what is the relation with respect to parameter means, see, this 3 we can write it as h plus 1, h plus 1. So therefore n is equal to 3 we can write it as h plus 1. Whereas n is equals to 7, we derived formula in the classroom by taking geometry progression. For example, if I consider here number of nodes are 1 means we can write 2 power 0, and at this level there are 2 nodes are there, therefore we can consider as 2 power 1, and at this level there are 4 nodes are available, we can consider as 2 power 2. Therefore, total number of nodes here 2 power 0 plus 2 power 1 plus 2 power 2. That is for n is equals to, for h is equal to 2, we are writing total number of nodes. This is equivalent to 2 power 0 plus 2 power 1 plus 2 power 2. Right friends, this is analysis for h is equals to 2. If we take for h is equals to h, we can make it as 2 power 0 plus 2 power 1 up to so on plus 2 power. If I consider h is equals to 2, I stopped at 2 power 2. If I take h is equal to h, we can stop at 2 power h. So which is equals to, it is following geometry progression. In geometry progression, sum of h plus 1 terms a into r to the power of h plus 1 minus 1 by r minus 1, which equals 2 power h plus 1 minus 1. Right friends, okay. So therefore, minimum number of nodes are h plus 1 and maximum number of nodes are 2 power h plus 1 minus 1. Based on this topic, there are frequently asking questions in the gate paper, okay. So therefore, we can make the relation, the first property, if n indicates total number of nodes, then minimum how many possible? Minimum h plus 1 nodes are possible. Maximum how many possible? 2 power h plus 1 minus 1 are possible. Minimum means skewed binary tree, max means full binary tree. So that is the first property you have to understand. And the second property, if you are talking about number of internal nodes, so number of internal nodes again depends on the what type of tree it is. For example, if it is skewed binary tree, number of internal nodes means root node also internal node, and this is also internal node, whereas this node is called leaf node, leaf node. So here there are 2 internal nodes are possible. Therefore, 2 means I can say height of the tree, correct? Height of the tree, we can say h. Height is equal to, and number of internal nodes also 2. Therefore, h less than or equal to I. And if you take full binary tree in this format, then number of internal nodes are 1, 2, 3. So 3 nodes are possible, internal nodes. So instead of saying 3, we can say 2 power 0 and then plus 2 power 1. If I take h is equals to 2, we are taking 2 power 0 plus 2 power 1. If I take h is equal to h, we can take it is 2 power 0, 2 power 1 up to so on 2 power h minus 1 we can take. Right? It means that what I am trying to say, if you take h is equals to h, we can say 2 power 0 plus 2 power 1 plus 2 power 2 up to so on just before the last level, that is 2 power h minus 1. Clear friends? Because if you consider last level, it is indicating total number of nodes. Therefore, 2 power h minus 1. Again, by summing up these values, a into r power h minus 1 by r minus 1. Okay. So therefore, in this case, total number of nodes are 2 power h minus 1. This is indicate total number of internal nodes. For h is equals to 2, you can substitute here. H equal to, so 2 power to 4, 4 minus 1, that equal 3 nodes are possible. Next one, total number of nodes are completed, internal nodes completed. Next we are talking about leaf nodes with respect to h. Third property, if it is skewed binary tree, number of leaf nodes are only one node here, right? Only one leaf node. Whereas if it is a full binary tree, number of leaf nodes are 2 power 2. 2 power 2 indicates that 2 power h. Therefore, I can say only one leaf node is possible and max number of leaf nodes are 2 power h. Right friends, 2 power h. So that's all. This is a relation among number of nodes and number of internal nodes and number of leaf nodes with respect to height of the tree. Clear friends, okay? And the second one is we can also express height in terms of number of nodes. Okay, that point also I will discuss now. Okay. And fourth property, if I consider, suppose if you are considering a tree which is left skewed binary tree, and then full binary tree, and also if I consider complete binary tree. You know, complete binary tree means all levels are full except possibly last level filling from left to right, that is called complete binary tree. Okay. So, all these trees are having height is equals to 2 only, height equals to 2. So, how do you express height in terms of number of nodes? In this example, height h is equals to 2, here also height h is equals to 2, in this case also height h is equals to 2. Then how do you express height in terms of number of nodes, friends? Okay. Whenever I am calling h equals to, h is equals to here number of nodes. For example, here you can consider this value minimum height and then maximum height. You can take this relation, from that relation you can derive the values. Okay. So, in this case, and h is equals to, I can say n minus 1. Number of nodes are 3 nodes, 3 minus 1. Therefore, h is equal to n minus 1. Whereas in this case, we know that 2 power h plus 1 minus 1 is equals to n, because total number of nodes is equals to 2 power h plus 1 minus 1. Since I want h value, I can bring like this, 2 power h plus 1 is equals to n plus 1, right. From this h plus 1 is equals to, bring to this side, it is acting as log base 2 of n plus 1, right, friends. From this we can say h is equals to log base 2 of n plus 1 minus 1. It means that minimum height and maximum height, if you are talking, minimum height is possible if more number of nodes are there at each level. Maximum height is possible if it is taking skewed binary tree. Okay. So, therefore, log base 2 of n plus 1 minus 1, here it is n minus 1. This is minimum height, this is the maximum height in a binary tree. So, therefore, you can say relation is minimum height of the tree and maximum height of the tree. Minimum height is equals to log base 2 of n plus 1 minus 1. Log base 2 of n plus 1 minus 1 is a minimum height, and maximum height is equals to n minus 1. That is possible only by using skewed binary tree. N minus 1. So, generally this height concept we are discussing with respect to complete binary tree, because most of the heap tree applications like inserting element into heap tree or deleting element from the heap tree, most of the operations based on only complete binary tree. Therefore, we have to focus on complete binary tree maximum height, complete binary tree minimum height. So, when you are talking about a complete binary tree, the complete binary tree having structure in this format. See here, it is a complete binary tree of height 2. Right, friends. I can also take complete binary tree of height 2 in this way. It is also complete binary tree. Complete binary tree means all levels are full except possibly last level filling from left to right. Last level filling from left to right. Here also it is filling from left to right, but it is not a complete binary tree. Therefore, complete binary tree point of view, minimum what is the height and the maximum what is the height, that is what we want to discuss now. Okay. So, I hope these points are clear. When it comes to complete binary tree, friends, just observe, minimum means up to height h minus 1 it is taking full binary tree, up to height h minus 1 is taking full binary tree, and extra one more node it is taking, correct. Whereas maximum is nothing but all levels are completely full, all levels are completely full. Therefore, how we are interpreting this statement now? This is a formula for maximum number of nodes in a complete binary tree, right? That is a formula for maximum number of nodes in a complete binary tree. So, when I am talking about a minimum number of nodes, I have to consider this case, minimum number of nodes. In that case, I want to remove this total part, friends. Okay. Right. In complete binary tree, If I consider n indicates total number of nodes, the total number of nodes are maximum 2 power h plus 1 minus 1. It is possible it is fully occupied. So, by using this approach 2 power h plus 1 minus 1, and minimum number of nodes are, it is taking up to h minus 1 plus extra one more node it is taking. It means that we can say that is nothing but minimum number of nodes 2 power 0 plus 2 power 1 plus 2 power 2 plus up to so on 2 power h minus 1. It is taking only up to last level, and last level we have only one node, that is plus 1. It is taking sum of h terms, so that is a into r power h minus 1 by r minus 1 plus 1. So, minus 1 plus 1 get cancelled, we will have 2 power h. Therefore, minimum number of nodes are 2 power h and max number of nodes are 2 power h plus 1 minus 1. By using this we can derive what is the minimum height, what is the maximum height. So, by equating these two, 2 power h less than or equals to n, from this we can say h less than or equals to log n base 2, that is the minimum height, maximum height. By equating these two, we will get minimum height, that is same as which we completed here, log base 2 of n plus 1 minus 1. Therefore, in complete binary tree it is having property, fifth property. Therefore, in complete binary tree fifth property, maximum height is bounded by log n base 2, whereas minimum height is bounded by log base 2 of n plus 1 minus 1. So, in the exam if they ask question, what is the maximum height of complete binary tree? Maximum height of complete binary tree is log n base 2 only. If they ask maximum height of tree, maximum height of binary tree, which is not a complete binary tree, in that case you can take n minus 1. Clear friends, okay? Repeating once again, in the exam paper if they ask what is the maximum height of complete binary tree, maximum height of complete binary tree is log n base 2, whereas maximum height of binary tree is n minus 1. Similarly, minimum height of binary tree, either it is complete binary tree or full binary tree or skewed binary tree, it is taking log base 2 of n plus 1 minus 1. Okay. So, these are five important properties you need to remember. So, based on these properties we have many questions friends, okay. We will discuss those questions also. Could you please confirm that is everything is clear or not? Okay. If it is clear, simply type CL in the chat box. I will give permission. Can you verify chat is enabled or not? Yes. Yeah. Please give response in the chat box. Now it is enabled. Right. So, most of you are giving response, it is clear. Right. So, first topic friends, okay. Let me solve some questions based on this topic so that we will get more clarity. Yeah. Yeah, this question we will discuss later because we have not yet covered. Just look at this one. A binary tree T has n leaf nodes. The number of nodes of degree 2 in that tree. Number of nodes of degree 2 in that tree. It's the most important topic friends, okay. Because based on these topics there are so many questions are there. So many questions. Minimum 5 times they ask this question in the gate paper. So, a binary tree T has n leaf nodes. The number of nodes of a degree 2 in that binary tree is. Okay. You also think about this problem. Meanwhile, I will derive one formula. You also think about this problem. So, to answer this question, first you need to understand K-ary tree. K-ary tree. K-ary tree means every internal node contain exactly k children. In K-ary tree, every internal node contains exactly k children. For example, if I consider a tree of this format, so there are 3 internal node. Every internal node contains exactly 2 children. For example, see, this is internal node having 2 children, correct? This internal node is having 2 children. This internal node is having 2 children. So every internal node is having 2 children. That's why this tree is called 2-ary tree. If every internal node is having exactly k children, that is called K-ary tree. If every internal node is having 2 children, that is called 2-ary tree. And if I consider another example, so in this case, every internal node is having exactly 3 children. So for example, here root node has also internal node, there are 3 children, and for this node also 3 children like this. Every internal node is having exactly 3 children. So this type of tree is called 3-ary tree. 3-ary tree. I can also draw 2-ary tree in this format. It is also called 2-ary tree, because every internal node is having exactly 2 children. That's why it is called 2-ary tree, friends. Okay. So this is the way you need to understand the definition of K-ary tree. Now, how this definition is related to the current problem? Actually, here they are asking about only binary tree, but I want to derive this formula for any type of tree, not only binary tree. Okay, it may be 3-ary tree or 4-ary tree, what it may be. For every binary tree, I need to derive the formula. This formula is most important formula, friends. Okay, so suppose if I say that if there are please excuse me. If there are I internal nodes, I number of internal nodes, L number of leaf nodes, in a complete K-ary tree, in a complete K-ary tree, then what is the relationship among internal nodes and then leaf nodes? So clearly I number of internal nodes are there and L number of leaf nodes are there, and it is a complete K-ary tree. And what is the relation between leaf nodes and internal nodes? Okay. Now for understanding that point, just observe, I am going to derive one important point here, that is, suppose if you take total number of nodes is equals to, in this example, how will you get total number of nodes? There are 3 internal nodes. First internal node, it is second internal node, it is third internal node. Right, friends? There are 3 internal nodes. Therefore, I am writing 3 internal nodes. Each internal node is contributing 2 children. For example, with respect to root node, these are 2 children. With respect to this node, there are 2 children. With respect to this internal node, these are 2 children. So each internal node is contributing 2 children. That's why 3 into 2 children. Plus one node is missing in the counting. Who is that? Means root node. That's why I am taking plus 1. Okay. With this 3 indicates that number of internal nodes. Number of internal nodes I defined it as I. Right, friends. This 2 indicates that number of children for each internal node. Number of children for each internal node I am taking it as K-ary tree. K-ary tree means that equals to every internal node is having k children. Therefore, K-ary tree plus 1. Right, friends. I into k plus 1. Whereas actually total number of nodes we can also write it as number of internal nodes plus number of leaf nodes. Just total number of nodes means internal nodes plus leaf nodes. I want to make the relationship between leaf nodes and internal nodes and K-ary values. Therefore, number of leaf nodes is equals to, by bringing I that side and taking I as common, I into k minus 1 plus 1. This is the most important relation which is useful for solving many problems. Okay, many problems we can solve. So, number of leaf nodes is equals to number of internal nodes into k minus 1, where k stands for K-ary tree plus 1. Clear, friends? Okay. Now, in this example, just observe, a binary tree T has n leaf nodes, means they already provided there are n leaf nodes, right? And the number of nodes in a degree, number of nodes of a degree 2 in tree. So, therefore, number of nodes of a degree 2 means I want to clean this board. Okay, if you want, you can copy immediately, take snapshot, otherwise nodes already available, friends. Okay. Clear? Just remember this formula, we will solve this problem. Actually, the number of nodes of degree 2 they are asking. Number of nodes of degree 2. I don't know how many nodes are there, just that is the reason I am taking, let I1 is equals to number of nodes of degree 1, where I2 is equals to, I am taking it as number of nodes of degree 2, number of nodes of degree 2. So, therefore, according to previous formula, total number of nodes n is equals to, number of internal nodes into K-ary tree k plus 1. But total number of nodes is nothing but internal nodes plus leaf nodes, right? Therefore, we are writing it as number of internal nodes plus leaf nodes is equals to I into k plus 1. Correct, friends? I into k plus 1. But in a binary tree, there are two types of internal nodes. What type of internal nodes? Two types of internal nodes. What are they? Internal nodes of degree 1, internal nodes of degree 2. Right? Internal nodes of degree 1, internal nodes of degree 2. Therefore, this I indicates that there are two types are there, I1 type of internal nodes plus I2 type of internal nodes plus L is equals to, here I indicates I1 internal nodes, where each internal node of degree, how much degree? 1. Means every internal node is having 1 degree. Therefore, I1 into k plus, again I2 internal nodes of degree 2. Therefore, I2 into 2 plus 1. Right, friends? So, from this I want to find number of leaf nodes. Therefore, I1 into 1, here also I1 into 1 get cancelled. Therefore, L is equals to 2I2 minus I2, that equals to I2 minus 1. What do you mean by I2? I2 indicates that number of internal nodes of degree 2. Number of internal nodes of degree 2. So, therefore, in this problem, in a binary tree, T has n leaf nodes. Therefore, in the place of L, they mentioned it is n leaf nodes. Please understand, n leaf nodes, friends. Okay, n leaf nodes. Here I have taken n is equal to total number of nodes. Please understand, it is total number of nodes. Total number of nodes. Here I am taking total number of nodes, right? Where total number of nodes means internal nodes plus leaf nodes, right? From this here, L is equals to I2 minus 1, but in the given problem, n indicates total number of leaf nodes. That's why I am taking L is equals to n, which is equals to I2 minus 1. Actually, what do you want here? The number of nodes of degree 2, they are asking, number of nodes of degree 2. So, number of nodes of degree 2 means obviously that is equals to I2. I2 indicates number of nodes of degree 2. Therefore, I2 is equals to, actually here it is plus 1, right? I2 plus 1, 2I2 plus 1. So, bring I2 is equals to n minus 1, right? What is n indicates here? Not total number of nodes. In this particular problem, they mention n is equal to leaf nodes, friends. Okay. Generally, we are taking n is equal to total number of nodes, but in this particular problem, they are taking n is equal to leaf nodes. So, only remember I2 is equals to n minus 1. Okay. What is n indicates? N indicates number of leaf nodes. This model question asked in 5 times in the gate paper. It is one question. Okay. One time they ask question, there are 200 leaf nodes are there. Okay. There are 200 leaf nodes are there. Then how many number of nodes of degree 2 are possible? How many number of nodes of degree 2 are possible? Simple answer, that is 200 minus 1, that equals to 119. And one time in the gate paper they are asking, there are 20 nodes are there of degree 2. Okay, there are 20 nodes are there. Sorry, there are 20 leaf nodes are there. How many number of nodes of degree 2 are there? Answer is 20 minus 1, that equals to 19. So basic idea is you have to remember number of internal nodes of degree 2 means number of leaf nodes minus 1. Okay, so I will show those questions also, you will get more clarity. See here, a binary tree T has 20 leaf nodes. The number of nodes in T having 2 degree, 2 children. So it is indicating that is 20 minus 1. 20 minus 1, that equals to 19. Yes, there are 200 leaf nodes are there. Therefore, answer to this question is 200 minus 1, that equals to 119. So could you please confirm that have you understood this model or not? Okay, if you understood, simply type U in the chat box. Clear, right? Yeah. Right. So this is the first model you have to understand, friends. Many questions came from this model. Please remember this model. Next one. This is regarding post order traversal. So which of the following sequence denotes the post order traversal sequence of the tree of the above question? Actually, question is missing actually. So I want to explain how to find post order traversal, pre order traversal, in order traversal in shortcut method. Try to understand. You can find this type of question in the gate paper. Okay. So for example, if I consider a tree, this question is not related to the given question, friends. Randomly I have taken one diagram, but I am explaining model questions, friends. Okay. So in binary tree, for every node, we need to maintain left child pointer and right child pointer. So node structure is looking like this. If I consider node A, so for node A, left side is pointing to left subtree, it is pointing to left subtree, and right child is pointing to right subtree. So we can say it is a node, it is left pointer, it is right pointer. Left pointer is pointing to left subtree and right pointer is pointing to right subtree, friends. Therefore, whenever you are traversing a tree, in tree there are, while traversing tree, just observe, first time you are touching node and then you are moving like this and you are coming back and you are touching second time. Afterwards you are completing right subtree and you are coming back to this place, this is the third time. Means every node we are touching 3 times, friends. Okay, 3 times. So based on the touching method, how to write pre-order traversal, in-order traversal, post-order traversal. So pre-order traversal and second one in-order traversal, third one is post-order traversal. Exam point of view, it is easy to apply in-order, pre-order, post-order. So this is a model question, GATE 96 model question, friends. They provided one diagram. They are asking which of the following sequence denotes post-order traversal of the above tree. Actually, the tree is not printed here. I am taking one random tree to explain this concept. Okay. So whatever answer you are getting here, this answer is not related to this question, friends. Please observe. So pre-order traversal means, so whenever you are traversing tree, it is first time you are touching, right? First time. When you touch first time, you can write in pre-order. Afterwards, you are traversing towards left subtree. Please excuse me. So actually leaf nodes are not having any subtrees. That's the reason we are making them as null pointers or null links. Let us start traversing the tree. Pre-order traversal, and then in-order traversal, and then post-order traversal. So pre-order traversal means when you touch first time you print in pre-order, and when you touch second time you print in in-order, when you touch third time you can print in post-order. So now traverse the tree starting from A. It is first time you are touching that node, therefore write in pre-order traversal. Second time you are touching, write in pre-order traversal. Sorry, first time you are touching B. It is first time you are touching B, D, write in pre-order traversals. Right friends, okay. Afterwards, you are second time touching this node, then write in order traversal. In order traversal. Afterwards, it is a null link. Third time you are touching this node, write in post order traversal. Right, continue this process for remaining nodes. So when you touch second time in order traversal, when you touch first time, it is pre-order traversal. Second time, which is in order traversal. Third time, which is in post order traversal. Third time, which is in again post order traversal. Second time, and then first time. Second time means in order traversal. First time means pre-order traversals. Again first time pre-order traversal. Second time and then third time. So F. Second time in order traversal. First time and then second time. So first time, that is in pre-order traversal. Second time in order traversal. Third time. Again third time. It is again third time. Right friends, okay. So this is pre-order, in-order, post-order traversal. You can apply this logic for all trees friends, okay. So that you will get concept about pre-order, in-order and post-order, okay. I hope this model is clear now, right. Yeah, these are regarding properties of binary tree just now explained. They are asking which of the following statement is false. Just observe, a tree with n nodes has n minus 1 edges. Obviously it is true, because every tree must contain n minus 1 edges, otherwise the tree become disconnected. In the spanning tree concept also I clearly explained, in a graph with v vertices it must have v minus 1 edges, right. So therefore first statement is true. Next, a label rooted binary tree can be constructed uniquely given post order and pre-order. Actually, we cannot construct unique binary tree with the help of post order and pre-order. Please understand, okay. We cannot construct unique binary tree with the help of pre-order and post order. Then how we are going to constructing unique binary tree means we can construct by using in order and pre-order and in order and post order. Unique binary tree is possible by using in order plus pre-order combination. Another one is in order and post order combination. Clear friends? Unique binary tree is possible by using in order pre-order and in order post order. But in the exam if they ask unique full binary tree, full binary tree means every internode is having exactly 2 children, right. So for example, if they ask unique full binary tree, so if they ask unique full binary tree, yes, then it is possible by using in order plus pre-order, and also it is possible for in order plus post order, and even it is possible for pre-order plus post order. You should remember these points, okay. If they ask unique full binary tree, it is possible to construct by using these combinations, okay. So why it is not possible to construct only in order traversal and only pre-order traversal means, you know that in order traversal if you apply for the given binary tree, there are so many combinations are possible, okay. So for given in order traversal, how many binary trees you can construct means 1 by n plus 1 into 2ncn, which is Catalan number which we discussed in the class. Suppose if they provide only in order traversal, how many binary trees you can construct 1 by n plus 1 into ncn. If they provide only pre-order traversal, how many you can construct? 1 by n plus 1 into 2n Cn binary is possible. Only if they provide post-order traversal will have same binary trees. It means that unique binary tree is not possible by using alone in-order traversal. By using alone post-order traversal, it is not possible to get unique binary tree. By using only alone pre-order traversal also, it is not possible to get unique binary tree. In such case, if you want to get unique binary tree, make the combinations. What are the combinations? In-order and pre-order you can use, or you can use in-order and post-order, provided that if they ask binary tree. If they ask full binary tree, it is compulsory you have to take any of the two, like in-order pre-order, in-order post-order, and in pre-order and post-order, like this. Okay. So I hope this concept is clear. Next, a complete binary tree with n internal nodes have n plus 1 leaf nodes they are asking. N internal nodes have n plus 1 leaf nodes. This is regarding complete binary tree. Just check whether are you understanding this question or not. A complete binary tree with n internal nodes having n plus 1 leaves. See, we can prove mathematically, or you can take simple example to prove this statement. For example, if you take complete binary tree, it is a complete binary tree. How many internal nodes are there here? One internal node. But how many leaf nodes are there? Two leaf nodes are there, right? Two leaf nodes. Let me consider one more. So it is also complete binary tree, right? Complete binary means all levels are full except possible last level filling from left to right. How many internal nodes are there? 1, 2, 3. And how many leaf nodes are there? 4 leaf nodes. So 3 internal nodes, 4 leaf nodes, n internal nodes, n plus 1 leaf nodes, satisfied. And another example, complete binary tree. So it is also complete binary tree, friends, because complete binary tree filling from left to right. Now verify how many internal nodes here. There are 2 internal nodes. But how many leaf nodes are there? Only 2 leaf nodes. So here they mention n internal nodes, n plus 1 leaf nodes. But we have 2 internal nodes, 2 leaf nodes only. Hence I can say this statement is false. Okay, this statement is false. So a tree with it's having n minus 1 edge is correct, and it is not correct because they are talking about binary tree can be constructed uniquely by using post order pre order is not possible. But if they ask full binary tree, yes, it is correct. If they ask full binary tree, it is correct. Next, the maximum number of nodes in a binary tree having height h equal 2 power h plus 1 minus 1. Yes, we already proved this one, right? Okay, so it is also correct. So what do you say? If you agree, simply type AG in the chat box. Type AG in the chat box, friends. Right. Next question. Yeah, this is actually general question based on binary tree concept. Okay, just read the question. I hope you already done this problem. Okay, I'll explain if you want. Consider the following nested representation of binary tree xyz. xyz is a nested representation where y and z are the left and right subtrees respectively, and further y and z may be null or they may be further nested. Y and z may be further nested. Okay, then which of the following represents valid binary tree? Based on the given condition, do you want 1 minute for solving this question? Yeah, you take 1 minute and try and post your answer in the chat box. Option C, right? Okay. See, the basic idea of this question is, if you take parenthesis x, y, z, where x indicates parent, where y comma z are left and right subtrays. So it is looking like this. X is a parent where y representing left subtree and z also representing right subtree. So this is a structure of the given tree, right friends? Okay, so it is y and it is z. Then what about the other characteristic about y and z? Y may be further nested. Y may be further nested. Further nested means compulsory it must have three elements. Three elements. Okay. Z may be further nested. Further nested means it may have three element structure. Right friends? Okay. So in that case, suppose if y and z are further nested, what is the pattern it is having? If y and z are further nested, we can write like this. If x is a root node parent and y is further nested, it must have three more elements like this. Okay, three more elements. Then we can say y is further nested. And z is also further nested, then z also having three more elements. So this is a case we can say y and z may be further nested. Let me check which is satisfying this case. See here, you consider x and you consider y, you can consider z. X is satisfying properly, y also satisfying properly, but z is further nested means maximum how many elements are allowed? Not maximum, exactly how many elements are allowed? 3 elements. But how many we are having? It is x, it is y, it is z, but what about 7? Right, it is invalid, therefore ignore this. Now in this case you can consider it is x, this total part whatever we are calling it is y and it is called z. So x is properly defined, z is properly defined, y is further nested. If it is further nested, then you can consider it is x, you can consider it is y, it is z. But inside that again x is further nested, x cannot be further nested, only y or z may be further nested. Therefore this pattern is not available. Okay, x cannot be further nested, only y and z may be further nested. Therefore you can ignore this one. Next, what about this one? It is x, it is y, and you can take it as z. Y is further nested, so we can take x, y, z. Yes, it is properly defined. Z is further nested, we can say x, y, z, which is also properly defined. Next, if you consider it is x and you can consider it is y, it is z. So again y is further nested, so x, y, z. They also mentioned that y and z may be null. Therefore it is valid, it is also valid, but it is not valid because if it is further nested, compulsory three elements are there. X is required, y is required, z also required, but z is missing. That's why this is not the correct answer. Okay, hence option C is the correct answer for this question. Clear friends? Okay, I hope most of you understood this problem. The same question, level order traversal of a rooted tree can be done by using root and performing. Actually level order traversal is nothing but BFS, breadth first search. Okay, so breadth first search we are calling level by level, that is called level order traversal, that we will discuss in graphs. Next, this question is related to array concept, array representation of binary tree. Okay, you also read the question, simultaneously draw the diagrams. By using questions I am able to revising all the concepts friends. Okay, it is the best approach for revising concepts. So in the array representation of binary tree, any binary tree, either binary tree or complete binary tree or full binary tree, what it may be, in the array representation of binary tree, they are using root node indexes starting from 1 instead of 0. Root node index is starting from 1 instead of 0. Therefore, I am taking root node index is 1. Right friends. For any left child, its index is 2i, right child they are taking 2i plus 1, that is equal to 3. Here it is 4, 5, 6, 7 like this. So they are storing these elements into the array where root node index starting from 1. So 1, 2, 3, 4, 5, 6, 7. Therefore A will be stored into first index, B will be stored into second index, C will be stored into third index, next D, E, F, G. D, E, F, G. Clear friends? Okay. In this case, what did they ask? For any node, just observe. For a node which is stored at index xi, the left child, if anyone is existing, it is stored at x of 2i, and right child, if anyone is existing, it is storing at x of 2i plus 1. Clear? X of 2i plus 1. What does it mean? For example, if I consider I equal to second index, friends, okay, I equal second index. What about its left child? Left child is equal to 2i. That's what they are saying. 2 into 2, that equal 4. What about right child? Right child is equal to 2i plus 1. This value equals to 2i plus 1. Therefore, in general, they are representing this. If you take any tree, suppose node x, if it is at ith index, its left child y at 2i, right child z at 2i plus 1. That's what they are discussing. Okay, and the parent of this node, something like a, must be at floor of I by 2. Floor of I by 2. For example, if I consider 3, who is the parent of index 3? That equal to index 1. Therefore, floor of 3 by 2, that equal to 1.5. Floor of 1.5 means 1. If you take 2, parent index equal to floor of 2 by 2, that equals to 1. Right, friends? This condition must and should hold. Now, what did they ask question? To be able to store binary tree on n vertices, the minimum size of the array they are asking. The minimum size of the array. So, what is the minimum size of the array? So, whenever they are talking minimum size of the array, you have to take all types of trees. To be able to store any binary tree they are asking, right? Any binary tree. Now, can you post your answer for this question? Actually, in the options, there are some corrections are required. It is not 2n, 2 power n plus 1. It is 2 power n minus 1. It is log n base 2. Can you please post answer for this question? Yes. Correct, you are right. Most of you are giving correct answer. Right, friends, okay? Since they are using the word is to be able to store any binary tree. To be able to store any type of binary tree, therefore, you take all types of binary trees, friends, okay? For example, if you consider left skewed binary tree, x, y, z with 3 nodes, and with 3 nodes, full binary tree is looking like this, x, y, z. With the 3 nodes, right skewed binary tree is looking like this, x, y, z. When you start indexing these elements, root node index is starting from 1, left child 1 into 2, 2, 2 into 2, 4. These are indexes. Therefore, the array structure is looking like this, like 1, 2, 3, 4. So, who is sitting first index? X. Who is sitting second index? Y. Third index is obviously it is null, okay, and fourth index is it equals to Z. So, for 3 nodes, size of the array is equal to n plus 1. For 3 nodes, size of the array equal to n plus 1 in this case, okay. So, if I take it is 1, 2, 3. First index, second index, third index, that is x, y, z. For 3 nodes, size of the array is equals to 3 now. Now, if root node index is 1, right child 2 into 1, 2, and right child again, 2 into 2 plus 1. Right child index is 2i plus 1, that equal 3, 2 into 3 plus 1, that equal 7. Because in the question they mentioned, right, for any index I, right child must be at x of 2i plus 1. Therefore, 2 into 3, 6 plus 1, 7, right. So, to store this binary tree, we need how many locations? 7 locations. 1, 2, 3, 4, 5, 6, 7. That equal, I can say x first location, y third location, and z at the 7th location. Remaining all are empty locations, null. It means that total how much size is required? 7 is required. Since they mentioned to be able to store any binary tree, therefore, I cannot say n plus 1, I cannot say n, right, friends, okay, because if you take n plus 1, it is not possible to store this binary tree, okay. So, therefore, it is not possible to take n plus 1, it is not possible to take n. So, therefore, answer is 2 power n minus 1. If n is equal to 3, 2 power 3, 8, 8 minus 1, that equals 7 locations are required. Therefore, answer is 2 power n minus 1. So, option D is the correct answer. To be able to store any binary tree, we have to use 2 power n minus 1, friends. Okay. Yeah. Just think about this problem. In this question, again it is using same formula which I explained earlier. Okay. Just read the question 1 minute. Is the speed is okay? If it is okay, simply type okay in the chat box. The speed is okay, simply type okay in the chat box. Okay, right? Right, option B is correct. Apply the same formula which I explained here. So, see the number of internal nodes of degree 1 is equal to 5 they mentioned. Number of internal nodes of degree 1 is 5. Suppose number of internal nodes of degree 1 we are defining it is I1. Earlier we discussed this problem, right? Okay. Number of internal nodes of degree 2 is 10. So, degree 2 means we can take it as I2. Degree 2 means I2. And the number of leaf nodes they are asking now, right? Number of leaf nodes. We have one formula, total number of nodes, internal nodes I1 plus I2 plus leaf nodes. Have you remembered this formula? Total number of nodes is equals to, means internal nodes plus leaf nodes is equals to I1 internal nodes, right? I1 internal nodes of degree 1, right? How many internal nodes are there? That is 5 internal nodes. So, number of internal nodes of degree 1 is 5. Let me take here I1 internal nodes of degree 1 plus I2 internal nodes of degree 2 plus 1. This is what we discussed earlier, right friends? Okay. Here I1 indicates that 5 internal nodes and I2 indicates that 10 internal nodes. We want to find leaf nodes is equals to 5 into 1 plus 10 into 2 plus 1, right friends? Okay. So, from this it is 15, here it is 25 plus 1, 26. So, therefore, number of leaf nodes equals 26 minus 15, that equals to 11 leaf nodes. This formula I already explained earlier. Total number of nodes is equals to number of internal nodes of degree 1 plus number of internal nodes of degree 2 plus k, sorry, plus 1. Is it clear? Could you please type CL if it is clear? Right. Yeah, this question asks max number of nodes of a binary tree. So, max number of nodes of binary tree which we already covered 2 power h plus 1 minus 1 friends. Okay. The properties of binary tree, max number of nodes of a binary tree equal to 2 power h plus 1 minus 1 is the answer. Okay. See the maximum number of binary trees that can be formed with the 3 unlabeled nodes. Whenever they are asking unlabeled nodes or labeled nodes, we can say n 1 by n plus 1 into 2ncn for unlabeled nodes. For unlabeled nodes. Therefore, substitute n is equal to 3 here, 1 by 3 plus 1 into 2 into 3, that equals 63, which equal 1 by 4 into 63 value equal 20, that equal to 5. So, answer to this question is 5 is the correct answer. Okay. If they ask suppose labeled nodes, for labeled nodes, the formula is n factorial into 1 by n plus 1 into 2ncn, because for labeled nodes n elements can be make permutation n factorial values. Okay, each way we can take 1 by n plus 1 into 2 NCN. In the notes I clearly explain how we are getting this one. Please refer why it is n factorial. Okay, so this is for label notes. Clear, friends? Right. If you understood, simply type U in the chat box, friends. Quickly type U in the chat box. I know I'm moving a little bit faster because I want to discuss more number of concepts today. Right. Yeah. Here it is a tree structure they provided. The in-order traversal they are asking. See, consider the following rooted tree with the vertex labeled as P as a root. The order in which the nodes are visited during the in-order traversal of the tree. In-order traversal of the tree. Actually, it is not a binary tree. It is a tree. It is a tree. Right. When you touch first time, it is taken as pre-order. When you touch second time, you can take it as a first time pre-order, second time in order, and third time it is post order. Apply the same strategy here. So sometimes you have to take options also. Just observe, by default this node is treated as a leftmost child, because every time by default we are taking node, child node always treated as a leftmost child only. So in that case, if I consider this tree, first time we are touching, right, that is pre-order traversal, but here they are asking the order in which the nodes are visited during the in-order traversal. They are asking in-order traversal means second time you have to print that value. The first time you are touching, then afterwards come to here, it is the first time you are touching, it is treated as leftmost child. Okay, you can consider the leftmost child like this. By default every node we have to consider the leftmost child, then you have to start here first time, then afterwards you are taking it is second time. When you touch second time you can print that value yes. So first one is yes, so all options contain first one is yes. Afterwards come to this place, it is third time, then come back to here, it is second time you are touching, here right child is null. So once you are touching second time you have to print that value SQ. So every time everywhere we are having SQ only, SQ. So afterwards come back to here the third time, then P is the second time. So second time means you have to print that value SQP. So everywhere we are having P also. Okay, SQP. Then come to this place first time, the first time, and then second time you are touching, there we have you have to print T now SQPT. So everywhere we are having SQPT. So afterwards come to this place, it is third time, so it is second time you are touching, now you have to print that value second time. Okay, SQPT R. So SQPT R here, here SQPT, here SQPT, here SQPT, here also R. So I can element option C and option B also, right, friends? Okay, so therefore after R then we are coming to this place, you know it is first time, it is leftmost child, so therefore it is first time, then you can process second time SQPT W. So therefore SQPT R W here, but you are having U, friends. So therefore answer this question is option A. You can continue this process for remaining trees also. Whenever you are touching second time you have to print this value. Okay. The height of the tree is the length of the longest path from root to leaf node. The maximum and minimum number of nodes of a binary tree. Yes, we already discussed, right? Maximum and minimum number of nodes. Binary tree they are asking, not complete binary tree. Okay, binary tree. So maximum is possible 2 power h plus 1 minus 1. Minimum is possible h plus 1. This is what we discussed in the beginning of the class. So therefore height is 5. So 5 plus 1 less than or equals to n less than or equal to 2 power 5 plus 1 minus 1. That is 6 less than or equals to n less than or equal to 31. Sorry, 2 power 6, right? 2 power 6 means like equals to 30, not 31. Sorry for the mistake. It is 63, right? So I got option A. What about you? Say yes. This option is correct. Someone is typing in order traversal always in increasing order. No. In order traversal not in increasing order. In order traversal in increasing order only for binary search tree, not for every tree. If it is binary search tree, then in order traversal always in increasing order, friends. Okay. This question already completed. 20 leaf nodes means 19 is answer. So while inserting the element 71, an empty binary search tree, the sequence of node in the lowest level. So I am taking this opportunity to explain how to construct binary search tree. How to construct binary search tree. Empty binary search tree. So binary search tree is satisfying the property that if I consider node X and it is having left subtree and also having right subtree. Usually left subtree key values are less than X and right subtree key values are greater than X. Okay, in the tree concept, duplicate elements are not allowed generally because primary key violation in the database management system. That's the reason I am taking only less than. Okay, if you want taken less than or equal to in remaining cases also. Generally we are taking database keys. Therefore left subtree key value is always less than parent, parent always less than right subtree key values. This is called binary search tree. So in this way, if you want to construct binary search tree, first node is 71, construct 71. Afterwards you are going to take 65. 65 is compared with 71. 65 is smaller than 71. That's why it should be left side. Then take 84. 84 is going to compare with 71. 84 is greater than 71. It comes under right subtree. Next 69. 69 is going to compare with the left parent. 69 is smaller than 71. Come to right subtree. 69 is greater than 65. So you insert here. The next one is 67. 67 is smaller than 71. Come to left subtree. 67 is greater than 65. Come to right subtree. 67 smaller than 69 comes to left subtree. Then 83. 83 is right of 71, left of 84. Then the question is the element in the lowest level they are asking. Lowest level means it is a root node. Next level, it is a next level. It is an element in the lowest level. So lowest level equals 67 is the answer, friends. Okay. If you say okay, simply type K, okay, in the chat box. Yes. See, these are the questions. This model is most important. Most of the question paper they are asking. Even last year paper also they asked this question. So just now I answered, right? The correct in order traversal sequence of what type of tree? Binary search tree. You know, in order traversal of binary search tree always in the increasing order. That is a most important key point. Okay. In order traversal of binary search tree always in the increasing order. Increasing order. Therefore, verify how many options are in the increasing order here. So 3, 5, 7, 8, 15, 19, 25 increasing order. 5, 8, 9, 12 it is not in the increasing order. 2, 7, 10, 8 not in the increasing order. 4, 6, 7, 9, 18, 20, 25 increasing order. Hence first and fourth one is the correct answer. So option A is the correct answer, friends. Okay. Is it correct? Option A, because second and third option is not in the increasing order. Yes. Right. Yeah, this is 200 leaf node question already completed. That is answer is 119. This is general questions, friends. Okay, application based questions. Okay, take 1 minute and try this problem. We'll discuss answer. It is application oriented questions. $199, Harish. By mistake I written 119, right? You are talking about previous question, no? 199. By mistake I written 119. Okay, 199, correct. Actually, this revision class really useful now because I am covering multiple topics within a short period of time using PYQ questions paper. It is the best approach for doing revision, friends. Okay, use PYQ book and do the revision from the class notes. If you directly read from the class notes, you feel bored. By using PYQ, you are able to recall all the topics. That is the most effective way of revising the topics. This is what I explained in the previous revision class also. Take PYQ book. By using PYQ book, you are able to recall all the topics which we covered. Yes, option C is correct. See, the numbers 1, 2, 3 up to 7 are inserted into binary search tree in some order. There is no specific order, in some order. Clear, friends? In some order, the resultant tree. The right subtree of the root contains how many nodes? P nodes. Right subtree of the tree contains P nodes. Then the first number to be inserted, they are asking. Right? For example, I am taking only 4 elements, 1, 2, 3, 4. It compels a sequence, 1, 2, 3, 4. In some order, randomly I am inserting in the binary search tree. You tell me some order, okay? So, some order I am taking, some order, whatever order you want, you can take 3, 1, 4, 2, suppose 3, 1, 4, 2. Now, I want to insert these elements into binary search tree. So, first 3 I am going to insert. Afterwards, 1 means left subtree and 4 means right of 3. 2 is equals to left of 3, right of 1. It is binary search tree. Okay. In this binary search tree, root node, right subtree contains P nodes. Okay. P is equal to 1 node. Right, 1 node. Then the first number to be inserted, they are asking. The first number means in this case, total number of nodes, how many we are having? N is equal to 4 nodes. N is equal to 4 nodes. Therefore, first number to be inserted, first number to be inserted. What is first number we inserted here? 3, which is equivalent to n minus p, right? N minus p. N is equal to 4 and p is equal to 1. P n minus p, 4 minus 1 that equal to 3. So, therefore, suitable answer is option C is the correct answer. Okay. You take any order. If you take in this order, you are getting this one. If you take some other order, for example, some order you can take 4, 1, 2, 3, for example, 4, 1, 2, 3. What is the binary search tree for this one? 4 is root and 2, 1 is a left subtree and 2 is left of 4, right of 1 and 3 is left of 4, right of 1, right of 2. This is binary search tree you are having. In this case, left subtree, how many nodes are there? 0 nodes. Therefore, P is equals to, sorry, right subtree. Right subtree 0 nodes are there. P is equal to 0 nodes. Right, P is equal to 0 nodes. Therefore, the first number to be inserted is equal to n minus p. N is equal to 4, 4 minus 0, that equal to 4. Clearly, first number to be inserted equal to 4, friends. Okay, first number to be inserted is 4. So, these are application based question. Never find this question in any textbook. Okay, student in a position to answer this question in the exam hall. Okay, as I mentioned, there are 4 models, right? Recall, analytical, application, and comprehensive based question. This question belongs to application based questions. Let T be a binary search tree with 15 nodes, the minimum and maximum possible height of the tree. So, this time they are asking binary search tree, minimum and maximum height of the possible binary tree. Okay. That binary search tree may be left skewed binary search tree, or it may be full binary search tree, or it may be right skewed binary search tree, right? Now, just answer this question because I already provided the formula for this in the beginning. Just post your answer in the chat box. Most of your providing answer is B. Means 3 and 14, right? Let T be a binary search tree with 15 nodes. You know, if it is 15 nodes, obviously it may be skewed binary search tree. Skewed binary search tree height is equals to n minus 1. Height equal to n minus 1. So, n minus 1 is 15 minus 1, that equal to 14. So, that is equals to maximum height. Maximum height is equal to 14. Right? Minimum height is possible if all levels are full. All levels are full. So, if all levels are full, total number of nodes formula n is equal to 2 power h plus 1 minus 1. Right? You are having total number of nodes how many? 15 nodes. So, 2 power h plus 1 minus 1. Bring this side. 16 is equals to 2 power h plus 1. We can write 2 power 4 is equal to 2 power h plus 1. When bases are equal, exponents are equal, 4 equals to h plus 1. from this h is equals to 3. Therefore, minimum height is equal to 3, maximum height is equals to 14. Clear? So, this is the way they are asking questions based on this topic, friends. Okay. Very few students posted answer for this question. Let me check why remaining people are unable to answer this question. Direct question only, right? That is regarding height. You are asking why did they give note? Note indicates that height here. Okay. The height of a tree with single node is 0. That note is not required for you. Why some people are posting answer A? Can you confirm that is it clear, everybody? Could you please type CL in the chat box? I am waiting for your response. Right. Right. The following numbers are inserted into empty binary search tree in the given order. What is the height of the binary search tree? Okay, you know, right? What is the height of the binary search tree? How to construct height of the binary search tree? So quickly I will do this one. So that equals to 10. 1 should be right of left of 1, left of 10. 3 is left of 10, right of 1. 15 right of 10. 12 right of 10, left of 15. 16 right of 10, right of 15. That's all. Then what did they ask in the question? What is the height of the binary search tree they are asking? Obviously, height is equals to longest path from root to leaf node. That equal to 2 is the longest path. Okay, 2 is the maximum distance. Therefore, answer is 2. Option is 2, friends. Okay. The post order traversal of a binary tree they provided, and in order traversal of the same binary tree they provided. The height of the length is the longest path from root to leaf node. Then height of the binary tree means, as I mentioned, binary tree can be constructed by using in order and pre order, in order and post order. Right. In this problem, they provided post order and in order traversal. Observe how to construct binary tree. If you know, you can also do practice along with me. The post order traversal which they provided 8967 45 231. This is a post order traversal they provided, friends. Okay, and in order traversal is 86947 2513. 2513. Have you remembered the procedure? If you want to construct binary tree by using in order and post order, you know, post order last node always root node, pre order first node always root node. Remember this concept, friends. Okay, pick up the last key of the post order sequence and create a node of it, because last key of post order always root node. Therefore, pick up the last key of post order sequence and create a node of it. That is 1. Afterwards, identify that key in order traversal. Identify 1 in that key in order traversal. Yes, here we are having 1. Okay, 1. Then these keys which are preceding 1 comes under left subtree of 1. Okay, and keys which are following 1 comes under right subtree of 1. So left subtree contains these elements, right subtree contains these elements. Means right subtree I have only post order, right subtree post order I have only one element, and in order also only one element, right subtree. Whereas left subtree I am having post in order traversal, left subtree 8 6 9 4 7 2 5. When in order is 8 6 9 4 7 2 5, post order also contains same elements. Post order also contains same elements, but order may be different. What are order here? 8 9 6 7 4 8 9 6 7 4 8 9 6 7 4 5 2 5 2. That's all. Okay. Now again continue this process, friends. Okay. Pick up the last key of the post order sequence and create a node of it. Identify that key in order. Identify that key in order. Again, left subtree of the keys which are preceding 2 comes under left subtree, keys which are following 2 comes under right subtree. Therefore, here left subtree and then right subtree. Left subtree in order traversal contains elements are 8, 6, 9, 4, 7, right. 8, 6, 9, 4, 7 automatically post order also contains same elements, but it is 8, 9, 6, 7, 4, right friends, okay. Whereas right subtree we have only one element, that is equals to post order 5 and in order also 5, in order also 5, clear. So, if you have only one element at deck, I can directly create a node. Here also I can directly create a node. Now, continuous process. I'm increasing the speed because we don't have time. Pick up the last key of the post order sequence and identify that key in order. Then 869 left subtree and right subtree is only 7. Correct friends? Only 7. Now, in 869 here 6 is the last node. Therefore, pick up the 6. Identify that 6 here. Then left is equals to 8 and right is equals to 9, that is all. So, this is your binary tree, right. Afterwards, what did they ask the question? The height of the binary tree they are asking. So, height of the binary tree is like 1, 2, 3, 4, height equal to 4. So, answer is 4. What do you say? Yes, 4 is correct. The pre-order traversal of a binary search tree they provided. Which of the following is a post-order traversal of binary search tree? So, this question pre-order traversal they already provided. I will explain the only procedure, we do not want to do it here friends, okay, because we want to discuss different types of problems. Pre-order traversal they already provided, is a pre-order traversal. Then what you have to do? You can find in-order traversal. You can find in-order traversal. Suppose pre-order traversal is 15. This is a pre-order traversal. You know that in binary search tree, in-order traversal always in the increasing order, right? So, therefore, take in the increasing order. So, if I take in the increasing order 10, 11, 12, 15, 16, 18, 19, they are in the increasing order. Once you know pre-order traversal and in-order traversal, you know how to construct unique binary tree, right? Okay. So, first pick up the first key of the pre-order sequence and create a node of it. Identify that key in order traversal. Then this keys comes under left subtree, this keys comes under right subtree. So, in the left subtree, we are having 10, 11, 12. So, these are 10, 11, 12. And right subtree we are having 16, 18, 19. I think one element is missing here. 3 plus 4, that equals to 8. Here I have written only 7. So, 20 is also there. Please excuse me. So, this is called right subtree. Please understand, it is a left subtree and it is right subtree. Apply the same process repeatedly. Pick up the first key of the pre-order sequence and create a node of it, 10. Identify 10 here. Identify 10 here. Then there is no left subtree, only right subtree is possible. That is 11, 12. Okay. For 11, 12, pick up the first key, that equals 12. Right, 12. After 12, identify 12 here and left subtree only possible, that equal 11. I am directly evaluating friends, okay, 11. Now, what about right subtree? Here first key is equal to 20. Therefore, pick up first key of the pre-order sequence, identify here. Identify that key. Then only left subtree is possible, 16, 18, 19. In 16, 18, 19, 18 is the first key. Therefore, create first key 18. Identify 18 here. Left is 16 and right is 19. Now, what did they ask the question? They are asking post-order traversal of this tree. Apply post-order traversal. You know post-order traversal process, right? The post-order traversal for this one, post-order traversal means you have to apply, or else you can apply touching method also. First time, second time, third time method. Okay, first time, second time, third time method. If you want, you can apply first time, second time, third time method. Okay. So, first time touching and then come to second time and then first time and then first time again here we are applying second time touching, correct. So, post-order traversal is 11, afterwards come to this place and 12. So, post-order traversal is always taking process left subtree process left subtree and process right subtree and then visit the node. Okay. Therefore, for every node come to left subtree. So therefore, first 11, afterwards right subtree is null, then 12. So that is 11 comma 12, afterwards 10, and come to the left subtree, right subtree, that equals 16, 19, 18, 20 and then 15. This is a revision class, friend. That's why I am running very fast. 11, 12, 10, 16, 19, 18, 20, 15. I got option A. What about you? Yes, option A is correct. Could you please confirm if speed is okay? If it is okay, simply type okay, because I feel that I am running very fast. Okay, right, fine. Next one. Yeah, this is one of the important concept of AVL tree. What is the worst case time complexity of inserting n square element into AVL tree with n elements initially already having? Here you need to understand time comes for inserting element into AVL tree. Inserting an element into AVL tree takes maximum time is equals to proportional to height of the tree. Okay, here I will take the opportunity to explain complete AVL tree process, friends. Okay, so that you will get more clarity. Okay. Which take it is theta of log n base 2. Okay, inserting element into AVL tree which take theta of log n base 2. But insertion requires several types of rotations. I will explain those rotations now. Suppose you are having only single node. By default, single node already satisfying AVL tree property, friends. Okay, AVL tree property. If I have one more node, let it be, assume it is 10, let it be, it is 8. Still it is satisfying AVL tree property. If I insert one more node, that is equals to, let it be 2. It is not satisfying AVL tree property. First of all, what is the meaning of AVL tree property? AVL tree property means it is taking one condition for every node x, balancing factors balance factor of x is equals to either -1 or 0 or 1. Means every node x, it is maintaining balance factor is either -1 or 0 or 1. Then only that type of tree is called AVL tree. Clear? Then what is a balance factor meaning? Whereas balance factor definition is balance factor of x value meaning is left subtree height minus right subtree height. I am not writing complete statement, please understand. Okay, left subtree height of node and right subtree of height of node, that is called balance factor. Clear, friends? Okay, that is called balance factor. For example, if I consider a tree for every node, if you want to find balance factors, always remember balance factor is sent from leaf towards root position. So for this node, balance factor is 0 because left subtree height and right subtree height is difference is 0. For this node, balance factor is left subtree height is 1, right subtree height is 0. So 1 minus 0, that equal to 1. Similarly, balance factor of this node is 0. Balance factor of this node is left subtree height is 1, right subtree height is 2. Therefore 1 minus 2, that equal -1. So here it is balance factor is 0. Balance factor of this node is left subtree height is 0, right subtree height is 1. 0 minus 1, that equal to -1. Right, friends? Okay. For this node, balance factor is left subtree height. What is the left subtree height? 3. Whereas right subtree height is equal to 2. So 3 minus 2, that equal to 1. For every node, if it is maintaining balance factor is minus 1, 0 or 1, then only it is called AVL tree. So clearly it is AVL tree. It is AVL tree. But first of all, AVL tree compulsory binary search tree. Please understand that point. Okay. AVL tree first of all it is binary search tree. A binary search tree which is maintaining balance factor is called AVL tree. That is also known as balanced binary search tree. Okay. Now see what are the properties you need to remember in AVL tree. Suppose if you are having tree in this format, it is binary search tree because 10 greater than 8, 8 greater than 2, it is a binary search tree, but it is not an AVL tree. The reason is if you take balance factors 0, 1 and it is 2, these are balance factors. This node is not comes under this range. Therefore, whichever node is violating AVL tree property, you can call that node as X. Its immediate child node in this path, you can call it as Y. Immediate child node in this path, you can call it as Z. Okay. Now, which node is not maintaining AVL tree property means X is not maintaining. So, why it is not maintaining? Because of insertion happen here. For example, if I close this node, if I have only these two nodes, they are already satisfying AVL tree property. But only because of insertion happen here, because of this node Z, it is not satisfying AVL tree property. Therefore, where insertion happen means insertion happening left of X. Tell me who is the left of X? Left of X is Y. Left of X is Y. For Y again it is taking left. You can read like functions composition discrete mathematics. Suppose H circle G of X if you consider, we can write H of G of X, right? In discrete mathematics. Means first you had applied G of X, you will get some value, on that value you can apply H. Clear friends? In the same way, left of X, who is the left of X? Left of X means Y. For Y again it is taking left. So insertion is happening in this way. That's why it is not maintaining AVL tree property. So whenever insertion happen left of X, you can perform single rotation clockwise direction. You can perform single rotation clockwise direction. Single rotation means in the place of X you can replace with Y. In the place of X replace with Y. Okay. Replace X by Y, and X is acting as right child of Y. X is acting as right child of Y. So therefore, I can apply single rotation. In the place of X, who is coming, friends? In the place of X, who is coming? Y. So therefore, I am taking Y. Where is X? X is right child of Y. Is any change in Z? No, there is no change in Z. There is no change in Z. Therefore, here Y is equals to 8, X is equals to 10 and Z is equals to 2. Now first verify is it a binary search tree or not? Yes, it is a binary search tree because 2 is less than 8 and 8 is less than 10. Is it maintaining balance factors? Yes, it is maintaining. So this is first model, friends. Okay, the first model. And second model, suppose imagine I am having node 10, by default it is satisfying AVL tree property, and I am taking 15 which is right of 10, still it is satisfying AVL tree property. I am taking 20 which is right of 15, but it is not satisfying AVL tree property because balance factors are not maintaining that range. Assign balance factor for this problem. It is 0. Balance factor this one is minus 1 because left subtree height is 0, right subtree height is 1. Balance factor is minus 2. Clear, friends? Okay. Balance factor always from leaf towards root position. That is a balance factor process you have to continue. So which node is violating AVL tree property? This node. You can call it as X. You can call it as X. Its immediate child node you can call it as Y because insertion happening in this path. Its immediate child node you can call it as Z. Where insertion happening? Right of X. Who is right of X? Y. Again it is right. Therefore, insertion is happening right of X. Right of X. Who is right of X? Y. Again for Y it is taking right. right friends. In this case you have to perform again single rotation, okay, you can perform single rotation. But this time you can perform anti-clockwise direction. Whenever I am saying single rotation, always think that replace x by y, okay. Single rotation means replace x by y, okay. So replace x by y. But whenever it is anti-clockwise, then x is acting as left child of y, So therefore, by bringing replace x by y, I am replacing x by y. X is acting as left child of y. Is there any change in z? No, there is no change in z place. Who is y here? Y is equals to 15, x means 10, z is equals to 20. Verify, is it satisfying ability property? Yes, it is satisfying ability property. Clear friends, okay. Only remember one important point, if it is single rotation, replace x by y, that is enough. If I replace x by y, where is the place of x? Where is the place of x? Where is the place of x means depends on the rotation. If it is clockwise rotation, x is right child of y. If it is anti-clockwise rotation, x is left child of y. That's enough friends, okay. Third case, if I consider node is something like 15, it is satisfying ability property. If I consider 10, it is satisfying ability property. But if I insert one more node, let it be 13, it is a binary search tree. How can I say binary search tree? 15 greater than its left child, and 10 is smaller than its right child, and 13 is smaller than 15. That's why it is binary search tree. Assign balance factors now. 0, minus 1, it is 1. So 0 minus 1, its balance factor is 2. This node is violating ability property, can call it as x. This node you can call it as y, and this node you can call it as z. Where insertion is happening left of x, who is left of x? Y, and then it is taking right. Therefore, insertion is happening left of x. Afterwards, it is taking right. In this case, you can apply double rotation. What do you mean by double rotation? Double rotation means in the place of x who is coming, z will come. Single means in the place of x who will come, y. So double rotation means replace x by z. Replace x by z. Simply replace x by z, friends. Okay. The moment if you replace x by z and it is performing rotation is clockwise direction, then what about x value? What about x value? X becomes right child of z. Okay, x become right child of z. Replace x by z first. Replace x by z, and here x is right child. There is no change in y place. And what about z? That equal 13. X value equals to 15, and then it is 10. See, it is not that much difficult topic. After rotation, you can verify is it binary search tree or not. If it is binary search tree, you can easily identify it is the correct answer only, right? Yes, it is a binary search tree. 13 smaller than 15, 13 greater than 10. That's a binary search tree, right, friends? Okay. Now, fourth category. Suppose I am having node is 15. Let it be 30. It is satisfying binary search tree property as well as AVLT property. One more node, let it be 20. Clear, friends? 20. Then this node having balance factor is 0. This node having balance factor is 1. This node is having balance factor is minus 2. You can call it as x. You can call it as y. You can call it as z. 15 is violating AVLT property because balance factor is not in the range. Therefore, you have to apply rotations. Where insertion happening? Right of x, and right of x again it is taking left. Okay, left. Right of x means y, again it is taking left. So what type of rotation you can apply? Double rotation. Double rotation means who is coming in the place of x? Z is coming. Means replace x by z. Then what about x value? X becomes left child of y, left child of z. Left child of z. So therefore replace x by z and x is left child, there is no change in y place. Therefore if you take x by z, that equal 20, after x value equal 15, it is 30. That's all. From this you should understand one important point, friends, that is, if it is single rotation, replace x by y. If it is clockwise direction, x becomes right child. Anti-clockwise means x becomes left child. So clockwise x always right child, anti-clockwise x always left child. Okay, that's all. Okay, is it clear up to here? Could you please confirm that is it clear or not? Right. Once you understand this process, inserting element into AVL tree which takes maximum height of the AVL tree, maximum height of the AVL tree, maximum bounded by log n base 2. Here I want to explain AVL tree of height 3, just observe. Minimum number of nodes of AVL tree of height h, I am defining it as n of h, n of h, clear? Minimum number of nodes of AVL tree of height h, I am defining it as n of h. In that case, for example, if we consider h is equals to 2, friends, okay, h is equal to, then how we are going to draw AVL tree means AVL tree of height 2 we can have in this format. It is AVL tree of height 2, right? Or I can also take AVL tree of height 2. It is also AVL tree of height 2. So I can continue like that, where AVL tree of height 2 also in this format. Clear? So whenever I am talking about AVL tree of height 2, it may have minimum number of nodes 1, 2, 3, 4. 4 is the minimum. It may have maximum number of nodes, that equals to 7 nodes, right? 7 nodes are there. Therefore minimum number of nodes and maximum number of nodes. Maximum number of nodes is easy to understand, 2 power h plus 1 minus 1, max number of nodes. Whereas minimum number of nodes, it is not possible to predict immediately. We need to construct recurrence equation. So observe how I am going to construct. Suppose if I take minimum AVL tree of height h, imagine it is AVL tree of height h. If it is height h, left subtree height is h minus 1, right subtree height is also h minus 1. Then what is the balance factor of this node x? Balance factor of this node x is 0. So it is valid AVL tree, valid AVL tree. Or else if I consider node x, left subtree may have height is h minus 1, h minus 1, whereas right subtree not having height h minus 1, it may have up to h minus 2, h minus 2. Then what is the balance factor of this one? Left subtree height minus right subtree height, that equal to plus 1, right friends, okay? Or else third case, maybe right subtree height is h minus 1, left subtree height may be h minus 2, h minus 2. Then balance factor of this node is left subtree height minus right subtree height, that equal to minus 1. These are the only 3 cases is possible if I say AVL tree of height h, because AVL tree is nothing but for every node having balance factor either 0 or 1 or minus 1, that's all. Among these 3 cases, in which case we will have max number of nodes? This case will have max number of nodes. That's what I explained here. So it is AVL tree of height h minus 1. It is AVL tree of height h minus 1. It is root node. Max number of nodes possible in this case. Therefore, recurrence equation for this one, if I take max number of nodes of AVL tree of height h is equal to m of h, max number of nodes of AVL tree of height h is m of h, then left subtree height how many nodes? M of h minus 1 plus right subtree also m of h minus 1. In addition to this, we can take plus 1. Okay. Repeating once again, maximum number of nodes of AVL tree of height h is m of h, then left subtree height is h minus 1, therefore m of h minus 1 nodes are there maximum, and right subtree height is also h minus 1, m of h minus 1 nodes are there. But one node is missing, right? Who is that node? Root node is missing, that's why I am adding plus 1, okay. So this is a recurrence equation for max number of nodes. If you solve this recurrence equation, you will get answer is 2 power h plus 1 minus 1 by using recurrence equation solving process. Either you can apply discrete mathematics recurrence relation solving process, or you can apply substitution method in algorithm subject. Okay. So it is a recurrence equation for maximum number of nodes, right friends? Okay. Minimum number of nodes, if you want to find recurrence equation, minimum number of nodes are possible in this case. N of h minus 1 here, it is n of h minus 2 plus extra root node. Therefore, minimum number of nodes of AVL tree formula, minimum number of nodes n of h is equals to minimum number of nodes of height h minus 1 means left subtree plus minimum number of nodes of height h minus 2 plus 1. 1 indicates root node. Okay, 1 indicates root node. Then what type of question they will ask in this paper? They will ask minimum and max number of nodes of AVL tree. Minimum and max number of nodes of AVL tree. They may ask the question, what is the maximum height? Let me write, actually I am not writing good handwriting. First question they may ask like, so if h is equals to, 3, then min comma max number of nodes of AVL tree. Here most of the students, they are facing problem in finding min number of nodes. Max number of nodes everybody can do it. Okay. So max number of nodes formula 2 power h plus 1 minus 1, 2 power 3 plus 1 minus 1, 15, right? 15. That is very easy, everybody can do this problem. But min number of nodes point of view, you have to recall the recurrence equation. Min number of nodes formula n of h is equals to n of h minus 1 plus n of h minus 2 plus 1, right friends, plus 1. Therefore, here it is equal to 3 they provided. So n of 2 plus n of 1 plus 1, because they provide height is equal to 3. But we don't know what is n of 2, right? Apply recursive approach. So n of 2 is equals to, substitute h equal to here friends. By substituting h equal to n of 2 minus 1, n of 2 minus 2 plus 1, right? We don't know what is n of 1, but we can understand n of 1 means minimum number of nodes of AVL tree whose height h is equal to 1. Whenever you are taking height h is equal to 1, minimum number of nodes means these are the minimum number of nodes, height h equal to 1. But if I consider full binary tree, it is not minimum number of nodes. Therefore, minimum number of nodes of height h is equal to 1 means how many nodes are there? 2 nodes are possible. Therefore, you can substitute 2. Minimum number of nodes of height 0, that means leaf node. Leaf node height is 0. Therefore, 1 node is possible, leaf node. So, 2 plus 1 plus 1, that equal to 4. N of 2 is 4, N of 1 is 2 already computed here, that equal to 7. Therefore, 7 nodes are possible if height of the tree is equals to height of the AVL tree equal to 3. Is it clear everybody? If it is clear, could you please type CL? So therefore, inserting element into AVL tree will take only log n time friends, log n time. Now come back to our previous question which we explained here. Come back to this question. The worst case time complex of inserting n square element in AVL tree. Inserting AVL tree is taking theta of log n base 2. Theta of log n base 2. So they are going to insert n square element. Simply most of the students they are doing like this. So n square elements means obviously one element takes log n square element means theta of n square log n they are doing. Okay. Of course, getting answer is important. How we are getting answer is not important. That is correct approach only. That is n square log n only. But actually, is supposed to do this problem in a different way. That approach I already explained in the class notes. You please go to the class notes because here it will take more time. So simple explanation: log n, one element insertion log n square means n square log n. That is okay, fine, but it is not the exact approach, friends. Okay, exact approach means already an elements already there here, right? Tree already contains n elements. Therefore, you have to continue this process. So after n elements, if you want to insert one more element, it takes log n plus 1, right? Next element log n plus 2. This is a first insertion, it is second insertion. Because your tree already having n elements, your tree already having an element, it is n plus 1th element, it is n plus 2 element. Like that we can continue this process. Okay. If we continue this process up to n square insertion. N square insertion means it is taking log of n plus n square, log of n plus n square. So therefore, it is again apply log a plus log b plus log c up to the formula that equals to log of a into b into c into up to so on n plus n square, right? Log abc. This is log abcd formula, log a plus log c, like this. Okay. If you observe here, just observe, it is n, it is n, it is n. How many times you are multiplying n in this case? N square times you are multiplying, right? N square times you are multiplying. Therefore, it is nothing but we can take log of remaining values if we ignore n to the power of n square times. For example, 3 times you are multiplying n into n, n square. So 3 times you are multiplying means n into n, n cube. Like that log of n to the power of n square. Remaining all are we can say lower order terms. Lower order terms. By ignoring lower order terms, I can bring n square here. By taking n square into log n, that equal theta of log n, theta of n square into log n. By ignoring lower order terms, bringing n square here, n square into log, sorry, n square into log n. So therefore, which is nothing but theta of n square into log n. Remaining values are lower order terms, friends. Clear? So this is the approach. Otherwise, most of the students they are doing simply one element is log n insertion, n square means n square log n. That is also correct approach. Okay. So post order sequence procedure call, we already discussed this type of problems. Binary tree contains 1000 distinct elements. This is a very interesting problem actually, right? So we'll take break now. After break, we'll continue this topic. Now time is 9. So 9 to 9:30 break, friends. Okay. I'm focusing only maximum time on trees concept only. Time is 9:05 plus 30 minutes break. We'll start class at 9:35. Most of the questions came from only nonlinear data structures, friends, like tree, hashing, and then graph concepts. Afterwards, you have to give priority to stack concept. Then you have to go for queue concept. This is the order of evaluation of the data structure topics. That is why I'm focusing maximum time on tree concept. Okay. Thank you. Yeah. Can you focus this question, friends? It's a very interesting problem. Suppose a binary search tree with 1000 distinct elements. Have you tried this question, friends? There are 1000 distinct elements. It is also a complete binary tree. You know, complete binary tree always filling from left to right. The tree is stored using array representation. You know, array representation means for any node whose index is I, left child at 2i, right child at 2i plus 1, parent at floor of I by 2, starting index of the array is 1. Okay. Assume that the array index is starting with 0. Instead of 1, it is starting with 0. The third largest element of the tree is available at which index? Can you post your answer this question because it's a very interesting problem. Try. Third largest element index. Let me check how many of you can answer this question. Please post your answer in the chat box, friends. Third largest element index. No one is posted answer. Yeah. Otherwise it is correct. Abhiram, can you check it once? Right. So we'll continue, friends. Okay. Please recall that formula. Total number of nodes in a complete binary tree, maximum is n is equal to power h plus 1 minus 1. Maximum right? So max number of nodes n equal to power h plus 1 minus 1, where h indicates number of levels or height of the tree, friends. Okay. Now, in this case, for example, I am assuming that root node is starting at level number 1, so level number 2, let it be level number 4, sorry, level number 3. If we consider here number of nodes, at level 1 we have only one node, right, one node. At level 2 we are having two nodes, but total number of nodes we consider, so here two nodes are available. At this point of time we are having four nodes. We can write 4 nodes are 2 square, it is 2 power 1 and it is 2 power 0, right, 2 power 0. So therefore, if I consider up to height 2, the total number of nodes 2 power 0 plus 2 power 1 plus 2 power 2, right. So therefore, total number of nodes here 4 plus 2 plus 1, that equals to 7 nodes. I can say n indicates 7 nodes, correct, 2 power h plus 1 means that equals to, we can say 2 power 2 plus 1 minus 1. So which is exactly matching, n equal to power h plus minus 1. So what I am trying to say, so first try to understand for 1000 nodes, how much height is possible. For 1000 nodes, how much height is possible? You need to find first height. So for 1000 nodes, for example, if you take n is equal to 1000 nodes, for 1000 nodes we are having 2 to the power of h plus 1 minus 1, correct. So bring it this one, that equal 1000 not 1 is equals to 2 power h plus 1, 2 power h plus 1. So suppose if you are having 1024 nodes, friends, here, okay, 1024 nodes. If you are having 1024 nodes, I can write it is 2 power 10, correct or not? 2 power 10. If you are having 1024 nodes, I can write 2 power 10, where which is equivalent to here right hand side, we can say 2 power h plus 1, 2 power h plus 1. So from this I can say h plus 1 is equals to 2, because h plus 1 equal to 10, because when bases are equal, exponents also equal. From this h is equals to 9. It means that if you are having 1024 nodes here, it is forming height up to 9, height up to 9. So height up to 9 means, like for example, here we are having height is equal to 2, height is equal to 2. So for height is equal to 2, we are taking height is equal to, this is a total number of nodes we are taking, correct. Ignore these two nodes. So if height h is equal to 2, total number of nodes 7 equal to 2 to the power of 2 plus 1 minus 1, by using this formula, n equal to power h plus 1 minus 1, right. Right, friends. Here they provided 1000 nodes. So 1000 nodes, if I write 2 to the power of h plus 1 minus 1, obviously I cannot write a power of 2. Suppose if I take it is 1024 nodes, I can write power of 2, then 2 power 10, that equal to power h plus 1, right, 2 power h plus 1 minus 1, for example, it is 2 power 10, you can assume that, okay. Let me write this one properly, please excuse me. Suppose you are having 1024 nodes or 1023 nodes you are having, just assume that. Then 2 power h plus 1 minus 1 is the formula. Correct friends, okay. Bring minus 1 to the left side, we are having 1024 which equal 2 power h plus 1, which is nothing but 2 power 10 that equal 2 power h plus 1. From this we can take h plus 1 is equals to 10 and h is equals to 9. It means that if you are having 1023 nodes, okay, if you are having 1023 nodes, then I can create a complete binary tree of height 9, Please listen this pattern properly. If you are having 1023 nodes, I can create a complete binary tree of height 9. But how many nodes are you having? You are having only 1000 nodes, right? 1000 nodes. It means that it is not possible to get all levels are full. It is not possible to get all levels are full. Up to what level all levels are full means up to height h equal to 8, all levels are full. Okay. So here it is up to h equal to, like that we can continue up to h equal to 8. So if I continue up to h is equals to 8, so it is full up to h equal to 8 friends, okay. All levels are full. Up to h equal to 8 if I consider, it requires only substitute h equal to 8 here, 2 power 9, that is 512 minus 1, that equal 511. Only 511 nodes enough for us, okay. If you are having 511 nodes, then up to h equal to 8 is completely full. But extra we are having some nodes, right. Therefore, those nodes comes under next level, like this, next level. It will be continued next level. But it will not continue till the last level. It will not continue till the last level. So therefore, what I am trying to say, this level up to, if we take earlier h is equal to 2, it is equals to 3. If it is 8, we can say it is 9, correct. Earlier I have taken height h equal to 2, therefore 1, 2, 3. If you take h equal to 8, I can take it is 9, right. Up to 9 levels completely full, but 10th level is not completely full. The final simple explanation, for given 1000 nodes, up to 9 levels are completely full, but 10th level is not completely full, somewhere else it is stopping. If you want to fill that last level also, you need 1023 elements, but you do not have 1023 elements, right. So that is reason by using 1000 elements, I can have 9 levels completely full, 9 levels completely full. Remaining nodes stopping somewhere else in the middle, right friends, okay. So this level having parent here, parent. So once you understand up to 9 levels completely full, now they are asking index of the third largest element, Now tell me what is the index it is taking. Suppose if we start from root node is equal to index is 0, right, it is 1, it is 2 and then 3, 4, 5, 6, correct. If I consider 0, 1, 2, 3, 4, 5, 6 like that, okay. So at this point of time, total how many nodes we are having at this point of time? 7 nodes. 7 nodes means it is starting from 0 to 6, right friends. It is starting from 0 to 6 if there are 7 nodes are there total. So by the time you reach here, 511 nodes are there, 511 nodes. 511 nodes means obviously this index must be equal to 510, right. This index is equals to 509. So if you understand up to this part, remaining part is so simple. So total 7 nodes means index is starting from 0, therefore last node index is 6. Total 511 nodes means index is starting from 0, that's why it is 509, it is 510, right. What about remaining nodes? Remaining nodes are not completely occupied here, clear. It is starting and it is moving from left to right. So up to this part is clear, right. And now focus here, they are asking third largest element in the root, third largest element of the tree stored in the index they are asking. What type of tree friends it is? It is complete binary tree, The tree is stored using array representation of the binary heap tree, So assume that the array indexes starts from 0, then the third largest element of the index is stored at. It is taking binary search tree. For example, if you take binary search tree, it is 80, left side value is compulsory less than 80, we can take it as 70, and right side value compulsory more than 80, let it be 90. Then who is the first largest, who is the second largest, who is the third largest? Root is actually right subtree contains first largest, it is the first largest, whereas root is second largest, okay, and it is called third largest. It means in the binary search tree, root node second largest, right child is first largest, left child is third largest. Now apply same logic here. Since it is a binary search tree and it is represented in the form of array and we are having 1000 nodes. So 1000 nodes means last level not completely full, it is full only half level. And it is a binary search tree, therefore in the binary search tree you know that all nodes left subtree must be less than root node, all nodes right subtree must be greater than root node. Therefore all these nodes are greater than root node, right friends. If I continue like that, this node is the largest element because it is not completely full, right, it is not completely full. Therefore it is a first largest element. If it is first largest element, its parent must be second largest element and its left child must be third largest element. Okay. Therefore third largest element is having index at 509. Repeating once again, in binary search tree, right child always first largest, parent always second largest and left child always third largest. By applying that property, for 1000 nodes we are not getting 9 level, 10 levels completely full, it is a 10th level, it is a 10th level. 10th level is stopping somewhere else the middle, somewhere else the middle. You are getting largest elements only in the right subtree, correct? You are getting largest elements only in the right subtree. Therefore, and the 9th level, up to 9 level completely full. If up to 9 level completely full, how many nodes are required? 511 nodes are required. If 511 nodes are there, index is starting from 0, then last node index must be 510. So that's why last node index is 510. If last node index is 510, previous node index is 509, correct? So its parent, it is having property, if it is its parent is there, its parent you can apply the formula of array representation of complete binary tree. Now the problem is to find second largest element, sorry, third largest element. So it is called first largest element, parent is second largest element and it is third largest element. Therefore answer to this question equal to 509. You practice one more time after completion of the class also. If you understood, simply type U in the chat box. No, I started with the level is level number 1. If I start level number 0, okay, but I start with level number 1, so it is correct only. Right friends, okay, clear, right? Next question. What about this one? If the binary tree in the following figure traverses in order, then which are the following nodes to be visited? So in order traversal I already explained, that's why I do not focus one more time. Just apply in order traversal, friends, okay? I think I covered all models in tree concept. Let me check some important problems. See the pattern of asking questions. A binary search tree is generated by inserting in order of the following integers. The number of nodes in the left subtree and right subtree of the root node is. You know how to construct binary search tree. After constructing binary search tree, calculate how many nodes in the left subtree and how many nodes in the right subtree. That is the process to do this problem. Okay, I am not evaluating this problem now because you know the process, we did already so many questions like this. I want to discuss some interesting problems. Yeah, it is a time complexity based question, friends. Okay. The worst case searching AVL tree is theta of log n time. Yes, AVL tree is a balanced binary search tree. Balanced binary search tree is always taking maximum height is log n. That's why the worst case running time for AVL tree is theta of log n, which is correct. Please excuse me. Which is theta of log n is correct. But that of binary search tree is the order of n. Maybe it is possible because binary search tree, it may be skewed binary search tree or full binary search tree, right? If it is skewed binary search tree, it is taking theta of n or order of n, right? So this statement may be correct. Next, the cost of searching. First, let me explain that searching operation once again. Suppose if the tree is in the form of skewed binary search tree, this is called skewed binary search tree. Assume that is 80, 70, and then 50. If you want to search x is equal to 50, the searching process will takes like this. 50 is going to compare with 80, 50 is smaller than 80, that's why you are moving towards left side. 50 is still smaller than 70, you are moving towards left side. 50 is smaller than 50 is equal to 50, that's why you are returning the index of that element. In this case, for searching this element, number of comparisons equal to total number of elements. Therefore, in this case searching process will take order of n, order of n. But if it is taking complete binary tree or full binary search tree in this format, suppose you are having 70, then 80 and then 50. 70, 80, 50. If you want such x is equal to 50, 50 is less than 70, that's a move towards left side. 50 equals to 50, which is matching, so then you can return index of that element. It means that whenever it is having full binary search tree, number of comparisons significantly reduced. Clear? How many comparisons are required means simply I can say 2 comparisons here, which equal height of the tree plus 1. Height of the tree plus 1. So therefore, search operation in binary search tree, please understand, search operation in binary search tree, there are 2 types of search operations. If it is skewed binary search tree, number of operations comparison we are performing theta of n. If it is a full binary search tree, number of comparisons are height of the tree plus 1. What is the maximum height of the complete binary tree? That equals to log n base 2. Log n base 2 plus 1, there is no importance of the constant, that's why it is theta of log n base 2. Clear? Whereas in binary search tree, order of n is possible or theta of n is possible and theta of log n is possible based on the structure. Here they mention order of n, yes it is possible. Next one, the cost of searching AVL tree is theta of log n, yes it is possible, but that of complete binary tree is theta of n log n, no it is not required. Okay, searching theta of n log n is not required. Clear? Next, the cost of searching binary search tree, it is taking order of log n, maybe it is possible if it is taking full binary search tree, right? But that of AVL tree is theta of n, no theta of n is not required, AVL tree always theta of log n only. The cost of searching an AVL tree is theta of n log n, no it is not correct, theta of log n only. Hence answer this question is option A. What about you? Is it okay? If it is okay, simply type okay in the chat box. Yes, Pavan, you can just apply the index formula, you can get second largest element. So already this type of questions we already evaluated. I think I covered almost all questions based on tree traversals, friends. Okay. This question also covered, right? So better to move next topic because I covered many questions here. I want to discuss one important model. There is one important model. Yeah, this type of questions also you need to practice. So this is called comprehensive based question, where they combined the concept of probability and statistics, right friends, and also the concept of full binary tree. Okay, can you answer this question, the 2019 problem? Have you tried this question earlier? Yes, only 2 students posted answer, means you didn't practice this question earlier, right? Yeah. They are asking expected distance between 2 leaf nodes, friends. Okay. How many leaf nodes are there total? Total 8 leaf nodes are there. In a full binary tree, every level is full and there are 8 leaf nodes are there. This kind of problems you need to practice, friends. Okay. Suppose 2 leaf nodes A and B of T are chosen uniformly and independently. It means there is no bias. Uniform means there is no bias. Okay, there is no bias. The expected value of the distance between A and B in T is, just I will give overall idea of this problem. Complete solution already given in the PYQ book, you can go through it. Especially DA students, you have to practice this type of models. So these are the leaf nodes in a binary search tree, friends. Okay, these are the leaf nodes in a binary tree, not binary search tree. It is from full binary tree only. Leaf nodes. Suppose if I call leaf nodes are with the names are like A, B, C, D, E, F, G, H. These are leaf nodes, right, friends? Okay. Now if I choose 2 leaf nodes randomly, so out of 8 leaf nodes, the first leaf node I can choose in how many ways? 8C1. 8C1 ways I can choose. Either I can choose A or I can choose B or I can choose C, like this. Okay, 8C1 ways. 8C1 means it may be A or it may be B, C, D, E, F, right, friends, and then G, and then H. That's all. I can choose any one of this node. After choosing next leaf node, because they are choosing 2 leaf nodes, they are choosing independently. Independently means selection of second leaf node do not depends on the selection of first leaf node. Therefore, again 8 nodes are there. We are choosing one more node, that is 8C1. Therefore, that selected node again it may be A. Along with A it may be A also, or along with A it may be B. Along with A it may be C, like that. Along with A it may be H. So therefore, total 8C1 into 8C1, that equal to 64 possible ways we can select. 64 possible ways we can select, friends. Okay. Afterwards, what you have to do, we can define one random variable x. X is a random variable. So it indicates the distance between 2 leaf nodes. The distance between 2 leaf nodes. What are the possibilities of distance between 2 leaf nodes here? If you take A comma A, the distance between A comma A is 0. The path length is maybe 0. Path length may be 0. Or if I selected A comma B, the path length between A comma B is 2. Just observe, friends. The path length from A to B, 2, because there are 2 edges are there, right? From A to B there are 2 edges. The path length from A to B is 2. Therefore, path length may be equal to. Or if I take A comma C, look at here 1, 2, 3, 4, right? The path length may be 4 also. X is a random variable which indicates path length. Or if you take A comma D also 4, but if you take A comma E, path length is equal to 6. So path length may be 6, right, friends? Okay, and every other node having distance path length is 6 only from A. It means that if you take any leaf node, what is the distance possible means it may be 0, distance between 2 leaf node may be 0, distance between 2 leaf node may be 2, distance between 2 leaf node may be 4, or it may be 6. Is there any possibility of getting path length of 8? No, 8 is not possible. That's all. Once you understand, then what you have to do, you have to find probability of path length x is equal to 0. Okay, probability of path length x is equal to 0. X equal to 0 means path length 0 means it is possible AA and then BB and then CC and then HH. So how many of them are contributing H is equal to 0 means like 1, 2, 3, 4, 6, 5, 6, 7, 8. Correct, friends? So therefore 8 are favorable to you. Therefore probability of length x is equal to 0 means 8 are favorable out of 64. Now they are asking expectation of the length, right? Expectation of the length. So therefore you can take expectation of x. You know the formula for expectation of x. Expectation of x means summation x into probability of x. That is the formula, summation x into probability of x. X means here 0, right? 0 into 8 into 8 by 64. Similarly, you can find path length of 2, okay, path length of 2. Similarly, you can find probability of path length of 4, find path length of 6, okay. After computing these probabilities, you can apply this formula x into probability. So x means 0 into 8 by 64, 2 into the probability, 4 into the probability, 6 into probability. You will get the expectation of x. So if you do like that, you will get answer is 4.32 is the answer. 32 or 12? 4.25, right? Okay. Sorry for the mistake. 4.25 is the correct answer. Kindly refer PYQ if you want complete solution, but this is the approach, friends. Okay, you need to practice. Is it okay with this explanation? Could you please respond? If it is okay, simply type okay in the chat box. Right, friends. Okay. Next, let me check some more interesting questions. Yes, this type of question is also interesting. They are basically properties of based on tree traversals. Can you post answer to this question, friends, in the chat box? Just post answer to this question. Mandeep, that is very easy problem only. That is only shortcut method for that. Okay. Right. So the logic for answering this question, most of you are already giving correct answers. They provided in order, pre-order, post-order traversal, but they don't know which one is which. Okay. So the logic is here, friends. The first key of pre-order sequence, first key of pre-order is same as last key of post-order. Last key of post-order. So therefore, here if you observe, it is a last key is K, first key is K. Here last key is H, no one else having first key is H, right, friends. So therefore, it is treated as post-order traversal. It is treated as post-order traversal, and it is treated as pre-order traversal, right? And obviously it is called in-order traversal. In-order traversal. So first one, just observe question options here. First one is pre-order, no. Second one is in-order traversal, no. Then second and third are pre-order and post in order. Second one is pre-order and third one is in order. So option B is the correct answer, friends. Okay. Option B is the correct answer. What about the first one? First and second are pre-order and in order. No, it is not correct. So option D is the correct answer. But most of you are giving answer option D only, right? Yeah. There are some questions they are asking programming based questions. You need to practice. I want to introduce one more problem. Yes. Can you check this question and post your answer in the chat box? Just try this question, friends. Yeah, Anil Kumar, can you check it once? Anil Nayak, it's okay. Anyone? Answer please. Yes, Arvind, it is correct. Gauri, it is correct. When searching for the key value 60, in a binary search tree, nodes containing the key values like 10, 20, 40, 50, 70, 80, 90 are traversed. They are traversed. But the condition is not necessarily in the given order. Okay? Not necessarily in the given order. Then how many different orders are possible in which these keys values can be occur in the search path from the root to the node containing the key value 60. So this is a question. First you should understand what is the meaning of traversed. What is the meaning of traversed? For example, if I consider a binary search tree, just randomly I am taking one binary search tree. Having key elements like, for example, if I take 100, 180, 120, it is 160, it is 40, 60, and then 50, here it is 20. Assume it is a binary search tree, friends. Okay, I want to search a key which is 40. Just assume that I want to search a key 40. Suppose if I ask the question, search a key 40. While searching key 40, what are the nodes we are going to examine? Obviously 40 is going to compare with root node, 40 is smaller than 100, that's why you search towards left subtree of 100, because binary search tree is maintaining ordering property, right? So therefore 40 is going to compare with 40. Yes, it is matching. It is matching. Suppose assume that it is not matching. Here I am having another element. Let it be. You can consider it is something like 48. Just assume 48. Now 48 is going to compare with 40. So 40 is going to compare with 48. 40 is smaller than 48. That's why you search towards left side. Here it is going to compare. But here there are no left subtree and there is no right subtree. After comparing 40 with 20, 40 should be greater than 20. You search towards right side. Right, friends? You search towards right side. But right side you encounter null. It means that search is completed but element is not found successfully. While searching this element, what are the key elements we traversed? 100, 48, 20. So therefore, while searching key, the elements which we traversed is 100, 48 and then 20. Clear? In the same way, while searching 60, what are the key elements they traverse means 10, 20, 40, 50, 70, 80, 90. These are key elements they traversed. Maybe the tree may be looking like this. See, first they are compared with 10, 10, but 60 is greater than 10, correct? 60 is greater than 10. That's why it may be towards right side of 10. Maybe here right side of 10 I am taking it is 90, 90. So then 60 is greater than, 60 is smaller than 90. That's why it should be left side of 90, correct? So left side of 90, let it be 20 I am taking. Then 60 is greater than 20. That's why we are search towards right side. Maybe right side I am taking element is something like 80, right? Now 60 is going to compare with 80, 80. 60 is smaller than 80, therefore you search towards left side. Suppose left subtree of 80, maybe it is 40. Then 60 is going to compare with 40. 60 is greater than 40, you search towards right side. Maybe right side you are having key element equal to 70. Now 60 is smaller than 70, therefore search towards left side. Left side you may have element is 50. Now 60 is greater than 50, but there are no elements to search. Clearly 1, 2, 3, 4, 5, 6, 7 elements traversed here. Okay. Total how many elements here? 1, 2, 3, 4, 5, 6, 7. 7 elements traversed. This is one pattern I explained. Like there are how many ways pattern it is possible they are asking. Okay. I can explain another pattern also. So starting from 90 and the left side we are having 80 and then next we are having 70. After 70 it may be 10, after 10 it may be 20, 20 afterwards it is maybe 40, it may be 50. Is it clear friends? It may be 50. Now you search 60, verify is it traversing or not. 60 is smaller than 90, that's it towards left side. 60 is smaller than 80, towards left side. 60 is smaller than 70, it should be towards left side. I have drawn diagram in the wrong approach, okay, please excuse me. Towards left side, then you can take 60 here, sorry 50, 50, again here you can take 40 and then 20 and then 10. This is one possibility. 60 is smaller than 90, smaller than 80, smaller than 70, smaller than 50. It is smaller than 50? No, right? It is not smaller than 50. Therefore 60 is smaller than 70, okay, but it is greater than 50. Greater than 50 means you have to search towards right side, right side. It means that this is not the correct way to traverse the tree, right? So in that case what you have to do, in order to encounter those nodes, here you can consider it is something like 40, sorry, you can consider, you can take it as, you can take it as 10. Now what happened? 60 is going to compare the 10, 60 is greater than 10, that's why you search towards right side. Now you can take it as 20, 60 greater than 20, that's why you search towards right side. Then we can take it as element is 40, but still 60 is greater than 40, you can take right side, which is 50. So this is a tree, other way we can traverse the nodes. Okay. If you observe these two examples, there is a similarity between these two examples, friends. One similarity is, please observe, there are two types of nodes here. One is keys which are greater than 60, keys which are less than or smaller than 60. There are two types of keys are there, right? So keys which are greater than 60, keys which are smaller than 60. There are two types of keys are there. So greater than 60 means there are three places, like 1, 2, 3 places, and then less than 60 values there are 4 places. There are 4 places. The complete idea for this problem is, it is compulsory you have to traverse 90 before 80 and 70, and you have to traverse 80 before 70, right? So therefore this is the order we need to follow. Therefore out of 1, 2, 3, 4, 5, 6, 7 locations, out of 7 locations I want to choose 3 locations. For what purpose 3 locations? In order to place 7, 90, 80, 70. Okay. So in order to place 90, 70, 80, let me clean this one, I will explain in easy way. We are having total 7 key elements, friends, okay. There are 7 key elements. So out of 7 location, we want to choose 3 location to place elements which are greater than 60. Therefore, out of 7 location, I am choosing 3 location. What purpose you are taking 3 location? To place 3 elements. What are the elements which are greater than 60? So after choosing those 3 elements, then we have to arrange them. How many ways we can arrange? Only one way we can arrange. What is that one way? It is compulsory in the decreasing order, 90 and then 70 afterwards, 90, 80 and then 70. This is only one way we have to arrange. Then only I can encounter all the keys, okay. Then only I can encounter all the keys. First I have to traverse 90, followed by 80, followed by 90. Only one way it is possible. So out of 7 location, I am taking 3 locations for placing 90, 80, 70, right. Remaining how many locations are there? 4 locations. So remaining 4 locations, out of 4 locations, we have to take 4 locations for placing remaining elements. What are the remaining elements? That is 10, 20, 40, 50. How many ways you can place them? Again only one way. What is that way? Compulsory in the increasing order, 10, 20, 40, 50. These are 2 independent tasks, we have to do one after another. Therefore, 7C3 into 1, that is 7C3 into 4C4, 4C4 is 1. Therefore, the total value is equal to 7C3 value, 7C3 value equal to 7 factorial by 3 factorial into 4 factorial, which is equal to 35. So, 35 ways we can do this problem. Let me explain how these 35 ways are possible. Suppose if you take 90, 80, 70, 90 here, 80 here and then 70, only one way I can arrange them. So afterwards 4 elements I can say 10, 20, 40, 50. It is one way, friends, it is one way. Otherwise, like by taking blanks, first it is compulsory I can take 90 before 80 and 70, before 80 and 70. So I can keep 80 here also here and 70. See ordering, relative position, 90 must appear before 80 and 70, that is all. 80 must appear before 70, that is all. What about 10, 20, 40, 50? Yes, 10 must appear before 20, 20 must appear before 40, 40 must appear before 50. It is other possibility. Or else, friends, we are having 7 locations. I can start from 10. But 10 should start from before 20, 40, 50. So let me take it as 20 here, 40, 50. Yes, 10 started before 20, 40, 50. 20 started before 40, 50, right? And 40 started before 50. What about these elements? I can take 90 and then 80 and then 70. It is also valid. Okay. Final explanation. You are having key elements, total 7. Suppose here I am taking 90. Then rest of the positions, it may be 80. Then compulsory it is 70. Now if it is 10, compulsory we have to take it is 20. It is 40. It is 50. So therefore, what I am trying to say, out of 7 locations, choose 3 locations to place 90, 80, 70. Right, friends? After choosing 3 locations, how many ways we can arrange in 90s, 80s, 70 means only one way, that is a decreasing order. In the same way, remaining 4 locations, you have to choose all 4 locations to place 10, 20, 40, 50. How many ways you can place? Only one way, that is increasing order. So 90, look at here, 90, 80, 70 is the decreasing order, 3 locations, and 10, 20, 40, 50 in the increasing order. Like that, how many combinations are possible? 35 combinations are possible. Okay. So like 1, 2, 3, 4. I can list out all the combinations. Or else in the discrete mathematics point of view, if there are n objects are there, if these n objects are divided into 2 groups, one group contain n1 object, another group contain n2 object, where total number of objects in group 1 plus group 2 is equals to n. Then the simple formula, total number of objects factorial by number of objects in first group factorial into number of objects in second group factorial. Okay. In the same way, total how many objects are there here? 7 places are there, right? 7 places. We are dividing the 7 places into 2 groups. One group contains all elements which are greater than 60. How many? 3 elements. Therefore, 3 factorial. Right? Other group contains all elements which are smaller than 60. How many elements are there? 4 elements. That is 4 factorial. So 7 locations we are dividing into 2 groups. One group contain all elements which are greater than 60. One group contain all elements which are less than 60. I think I am explaining like regular class, not a revision class. Sorry to bother you, but this is a best explanation I feel. If you really love it, simply type L in the chat box, friends. Okay. Because in the social media also you are unable to find correct answer for this type of questions. Is it clear, everybody? Yes, I will wait for 2 more minutes. If anybody is having doubt, you can ask me, friends. Okay, type in the chat box and ask. Sir, how we selected 3 elements should be in the increasing order. It is common sense only, right, Navya? You are asking if it is not in the increasing order, what will happen? You are asking. Somebody is asking like that. Okay. Okay. If you are not in the increasing order, I am taking like this: 80, 80, 90, 70, and then it is not in the increasing order, right? Correct. Next one, I am taking 10, 30, and then 20. No, 30 is not there. 10, 50. I want to answer that question because some of you are asking, sir, if it is not in the increasing order, what is the problem? 10, I am taking 50, and then 40, 20, right? So clearly I have not taken the increasing order or decreasing order. See, what is the reason I mentioned this should be in the decreasing order means, first if you take root node is 80. To whom you are comparing? You are comparing with 60, right? 60. So 60 is smaller than 80. Smaller than 80 means your search towards left side only. If your search is towards left side, you cannot encounter 90. You cannot encounter 90 because 90 must be in the right side, correct? So only you can encounter 70. Therefore, you are missing 90. I hope you are understanding. That's why it is compulsory in the decreasing order only. Okay. So 90, 80, 70. Then only you can traverse all the nodes. Is it clear? In the same way, suppose if you take 10, 50, 40, 20, what is happening? Suppose you are taking 10 here, 10. After 10, okay, you are taking 50. 50 means it should be right side. It should be right side. Therefore, 60 is greater than 10, 60 is greater than 50. Then you are moving towards right side of 50. If you are moving towards right side of 50, you cannot encounter remaining elements. You cannot encounter 40 and 20. Is it clear? Am I answering your question? Have you understood the importance of increasing and decreasing? I need quick response, please. Yes, Abhiram, Navya. Right. So that is the reason I asked you to arrange them in the increasing order for 10, 20, 40, 50 and remaining elements in the decreasing order. Yes. What about Nakka Pawan Kumar? Something you gave question but you didn't respond back. I'm waiting for you. Right, it's okay. After asking question, if explanation is given, you have to respond in chat box, friends, so that it is not wasting other people time, right? Yeah, this model is also very important model. Okay, can you try this problem? This model is also very important model, friends. Okay. Yes, come sir, that's what I explained in the explanation. Nitin Saint, you asked me question afterwards, you didn't respond back. You understood, right? Okay, thank you. Thank you, Nitin. Next question you can try, friends. Right. It is same as previous problem, friends. Okay. A binary search tree stores values in the range from 37 to 573 of the following sequence of keys. So, this is the following sequence of keys. Suppose the binary search tree has been unsuccessfully searched for the key 273. It is unsuccessfully searched for the key 273. Which of the above sequences list of nodes in order which we could encounter them in the search? Same process. Okay. Just start first one. They are comparing 273 with 81, but 273 is greater than 81, right? Actually, binary search tree contains so many elements. They are asking about traversing the sequence, traversing sequence, which we discussed in the previous question. So 273 is greater than 81. That's why I have to search remaining elements only greater than 81. So clearly, all these elements which are greater than 81 only. Okay, means after comparing with 81, you are going to encounter remaining elements which are greater than 81 only, because 273 is greater than 81. So next I am entering into 537. It means you can imagine there is a binary search tree to whom they are comparing. They are comparing with 81. 273 they are comparing with 81. So 273 is greater than 81. That's your search towards right side. Your search towards right side. It means right side all elements compulsory greater than 81 only. Greater than 81 only. So clearly all elements are greater than 81. Now 273 is going to compare with 537. But 273 is smaller than 537. That's your search towards left side. It means all elements left side must be less than 537 only. Means remaining element must be less than 537. Yes, all elements are less than 537. Like that we can continue the process. 273 greater than 102. That's the remaining all elements are greater than 102. Yes, all elements greater than 102. 273 smaller than 439. That's the remaining elements all are smaller than 439. 273 is smaller than 285. Therefore, your search towards left side of 285 means all elements are smaller than 285 only. But I encounter here 376, 305, which is not the right process to search. Means after comparing the 285, you cannot encounter 376, you cannot encounter 305. Next, what is the problem in the second one? 273 greater than 52, that's why all elements are greater than 52 only. After 92, all elements are greater than 92. After 121, all elements are greater than 121. After 195, all elements greater than 195. After 242, all elements greater than 242. Now the problem is 273 smaller than 381. If it is smaller than 381, you have to search all elements which are less than 381 only. But I encountered 472, which is not possible. Okay, which is not possible. Next one, 142. Okay, 273 is greater than 142. That's why all elements are greater than 142. Right, friends? So 273 greater than 248. 273 greater than 248. Therefore, all elements are greater than 248. 273 is smaller than 520. That's why all elements are smaller than 520. Next, 273 is smaller than 386. All elements are less than or smaller than 386. 273 is smaller than 345. That's why remaining all are smaller than 345. Next, 273 greater than 270. That's why this element is greater than 270. Finally, you are comparing with 307, but that element is not successfully found. They clearly mention unsuccessfully found, right? Unsuccessfully found. That's why it is correct answer. Third one is correct. Now, where is the mistake in fourth one? Can you answer where is the mistake in fourth one? Which key is facing problem in fourth one? Is it possible to search by using fourth one? Quickly, which element is facing problem? Fourth one. Yes, exactly. After searching with 395, it is not possible to have 463. Okay, it is not possible to have. That's all, friends. These are different types of questions asked in tree concept. Okay, we successfully completed tree concept, right? I'll wait for 2 minutes. If anybody is having issue, you can ask me. The tree concept is over. If you are happy with the tree concept, simply type H in the chat box. Type H in the chat box, friends. Whichever topics are high priority topics, only those topics I am discussing, friends. Right, thank you. Which topic? Because we are having less amount of time now. So I am planning to start hashing now. Hashing will take less amount of time and compared to remaining topics. Today is Vaikunta Ekadashi. I pray God to give good strength and good health and good education for every one of you. Manideep, heap tree comes under algorithm subject. In algorithm subject, I will teach heap tree. Okay, heap tree we are not discussing data structure, Mandeep. First, let me explain some theory part regarding hashing. So, the primary object of hashing is to search a key from the hash table with the order of one time. Okay, with the order of one time. You know that in binary search tree, searching time will take order of n to order of log n. order of n to order of log n. To reduce this drawback, we move to the AVL tree concept. When AVL tree, searching tree always will take order of log n base 2. If you go to database management system, there are advanced tree concepts like B tree and B plus tree also, where B tree and B plus tree, if you consider B tree of order m, B tree of order m, it takes time complexity, that is order of log n base m, order of log n base m. Clear? This is a B tree of order m. Next, even B plus tree also will have same time complexity, B plus tree also. Okay. For example, if you take database table, if you want to search data from the table, it takes order of n time, because table is nothing but relation. So, from the table, if you want to search data, in the worst case it may be found in the last place, therefore it takes order of n. Suppose we are having n is equal to 1024 elements, it takes 1024 comparisons searching data from the table. But if it is taking binary search tree, in the worst case it is also taking 1024 comparisons. If it is full binary search tree, it is taking log 1024 base 2, that equal approximately 10 comparisons only. See how much difference is there, how much difference. Here 1024 comparison, here only 10 comparisons, right. AVL tree always it is taking 10 comparisons only, log 1024 base 2, that equal 10 comparisons. Okay. In AVL tree, why we are taking base 2 means, for example, in AVL tree structure, if you consider, if it is x, each node is having 2 child pointers, they are called child pointers. So, 2 child pointers indicating here base value, log base 2, 2 indicates 2 child pointers. Whereas in B tree of order m, for example, if you consider B tree of order 5, B tree of order 5, 5 means there are 4 key elements are there, okay, 4 keys are available. If there are 4 keys, I can say key 1, key 2, key 3, key 4, 4 keys. Then it is a pointer pointing to all keys which are smaller than K1. Second pointer pointing to all keys greater than K1 less than K2, right. Here it is pointing to all keys greater than K2 less than K3, greater than K3 less than K4, greater than K4. If one key element is there, 2 child pointers. For one key, 2 child pointers. If there are 4 keys, how many child pointers? 5 child pointers. That's what is called B tree of order m. For one key, 2 child pointers means log base 2. For 4 keys, 5 child pointers means we can say log 5 base n, like this. Okay, log n base 5, log n base 5, where 5 indicates order of the B tree. In this example, if you take 1024 elements, which equals to log 1024 base 5, approximately this value is equals to how much it is taking, log base 5, I can say it is 5 to the power of 5, approximately I am taking 5 to the power of 5, right. So, therefore, we will get only 5 into log 5 base 5, that equal 5. See, from the table, if you want to search data, it is taking 1024 comparisons. Binary search is sometimes 1024, sometimes 10, whereas AVL tree always 10 comparisons. Still we are not happy, we move to B tree or B plus tree in database management system. It is taking only 5 comparisons. See how comparisons are significantly reduced. Starting from 1024 came to 5 comparisons. Still we are not happy with this. That is the reason we are moving to another topic, is called hashing. Hashing. In hashing, what happened? Suppose if we are having database, in the database there are some key elements are available. In the database there are some key elements are there available. These key elements are hashing to another table is known as hash table. Another table is known as hash table. So, in a hash table we are having 2 columns. One is called index, another one is called key. So, how they are hashing? For example, you are having key elements are 20, 31, 42, 53. They are key elements. We want to hash this key element into index. If I consider hash function, h of x is equals to x mod 10, x mod 10. This 10 indicates that hash table size. If hash table size is 10, index is starting from 0, 1, 2, 3 up to so on 9, right friends. Okay. Now I can hash this value to the hash table by using hash function. I can substitute here h of 20 that equal 20 mod 10 which equal to 0th index. So it is moving to 0th index. Clear friends, okay. Afterwards I can substitute 31, h of 31, h of 31 will go to 31 mod 10 which equal to first index. Therefore 31 will be stored into first index. Similarly 42 will go to second index, 53 will go to third index. Like that we are hashing database keys into hash table. After hashing, if you want to search from the hash table, it takes only constant time. For example, I want to search 42. If you want to search 42, substitute 42 here, okay. Substitute 42 in the hash function, h of 42 that equal 42 mod 10 that is equal to second index. It will directly hash into second index now. It takes only constant time. Algorithm point of view, time complexity is nothing but frequency count of fundamental operations. How many fundamental operations are there here? Only one fundamental operation. When one fundamental operation is there, how much time it is taking? Theta of one time, right? So therefore, hashing will take theta of one time. We started our journey from theta of n or order of n, theta or order doesn't matter here, okay. So we started our journey from theta of n, we came to theta of 1. But where is the issue? Why lot of research is going on hashing? Why they are still inventing different types of hash functions? The issue is if multiple key values are hashed into same location. Here distinct key values are hashed into distinct location, that's why it is very good hash function. Suppose if multiple key values are hashed into same memory location, then it occurs collision. If collision occurs, we want to resolve the collisions, okay. So while resolving collisions, we are discussing 4 techniques: linear probing, quadratic probing, double hashing, and then separate chaining. 90% of questions, 80% of questions from linear probing, 10% of questions from separate chaining, remaining 10% theoretical concepts like what is a load factor, okay, and quadratic probing one question is in 2022 paper like this. But most of the questions came from linear probing. So this is the overall idea about the hashing, friends, okay. Now let me explain basic concept of linear probing and all. If we consider hash function, hash function generally we are defining h of x is equals to x mod m, okay, x mod m, clear. So how do we resolve the collisions? By using linear probing, okay. So first technique is linear probing. In linear probing, if you take h of x equal to x mod m, suppose assume that it is meeting to the some location is called k. If kth location occurred collision, if kth location already having key, then collision occurs. If it is already having key, then collision occurs. So if collision occurs in linear probing, how it is going to search? Just observe, friends. In the hash table m, index are starting from 0, right? 0, 1, 2, 3 up to so on. Suppose you are having k minus 1, k plus 1, k plus 2 up to so on m minus 1. Try to understand how linear probing is working. Suppose first it is hashing to kth location. So we will go and check is kth location is empty or not. If kth location is empty, there is no collision occurs. If kth location already occupied, then collision occurs. In linear probing, it says that if kth location occurs collision, then go to k plus 1 location simply k plus 1 location. That's why in linear probing hash function hi of x is equals to original function h of x plus 1 means I into mod m. H of x plus I into mod m. What is I here? I indicates collision number, okay, where I is equals to collision number. Where I indicates collision number. Clear friends, collision number. So, if the kth location occupied by key, then you have to search in k plus 1th location. It is also having collision, then go to k plus 2 and also go to k plus 3. Continue that process up to m minus 1. Then you can apply wraparound sequence. Wraparound sequence means after m minus 1, again it is starting searching from 0, 1, 2, 3 up to so on k minus 1. This is called wraparound sequence. This is the way how linear probing is working. But what are the drawbacks of linear probing means, if key is stored into k, next location k plus 1, next location k plus 2 means group of keys are clustered in sequential locations. Sequential location. For example, just imagine the table. Index and then key. Index are like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So, I am having key values are just imagine their key values, right friends, okay. Then if I take h of x equals to hash function x mod 10, first you can substitute 10 here, 10 mod 10 that equals 0th location. So, it will move to the 0th location. Afterwards, if I take h of 20, so 20 mod 10 again 0th location, but 0th location already key element is there. Then where you have to search next location, right, because of this function h of x plus I mod m. So, therefore, it is taking 20 next location. Next 30 also map into 0th location, but 0th location already occupied with key. Then go to next location, again key element is there, next go to next location that equal to 30. In this fashion we are going to fill up remaining all elements, 50 and then 60, 70, like that we are going to fill up all the elements, okay. Then where is the issue here? Suppose if you want to search h is equals to 70, then 70 mod 10 that equals 0th location. I will go to 0th location, but 70 is not available here. Then where I have to search? I have to search in first location. Here also 70 is not possible. You have to continue that process till you find the 70. In the worst case, it is taking again theta of n time. Theta of n time. Clear? This is called primary clustering problem. Primary clustering problem means if group of keys are clustered together at one place in sequential locations, okay, searching take more time. This is called primary clustering problem. So, which problem is suffering linear probing? That is primary clustering problem. This primary clustering problem can be resolved by using quadratic probing. In quadratic probing, we are using function is called hi of x is equals to h of x plus, in the place of I can take I square, that is called quadratic, okay, I square mod m, I square mod m. Clear friends, okay. So, what is the drawback of quadratic probing? Because of I square, even though some locations are empty in the hash table, we are unable to map to that location. For example, assume that there is hash table having elements having index like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right friends, okay. 10 means total 11 locations are there, 11 locations. For example, if any key is hash into some third index, for example, assume that it is hash into third index. If third index having collision, then where I have to search? So, apply quadratic probing. So, shall I clean this part, remaining part, because I need space for otherwise I will move like this, just observe. Yes, interesting, just listen. Suppose for example, I'm taking an element that equal to h of 30, where your hash function h of 30 is equals to 30 mod 10, that equal third index. So therefore h of 30 equal to third index, but third index already having some element key x. Then what happened? It is having collision. Collision. It is first collision, collision number 1. Collision number 1. If it is collision number 1, you can apply quadratic probing. H1 of 30 is equals to formula h of 30 plus 1 square mod 10. Okay, mod 10. If it is mod 10, I can make it as only 9. Clear friends, mod 10. Right? Afterwards, h of 30 is equals to 1. Sorry, h of 30 equal 3. So that equal 3 plus 1 square mod 10. Where we'll get fourth location, right? 3 plus 1 is fourth location. Assume that fourth location also we are having key element is y. Fourth location also we are having key element. Then second collision occurs. Collision number 2. If second collision occurs, we need to compute h2 of 30, which equal to h of 30 plus 2 square mod 10, where h of 30 is equal to 3, 3 plus 2 square mod 10, that equals to 7 mod 10, that equals 7th location. Assume that 7th location also we have one element here, z, means collision occurs, right? So therefore collision number 3 occurred. Then I had to go for h3. h3 of 30 is equal to h of 30, h of 30 means 3 plus 3 square, h of 30 means 3 plus 3 square mod 10, because here collision number is 3, that is why I square means 3 square mod 10. So 9 plus 3 12, 12 mod 10, that equals second location. 9 plus the second location. So assume that second location also we are having one element w. Okay. So again collision. Collision number n is equals to, collision number I is equals to, I think it is 4, because 3 collision already happened, 4 collision. If it is 4th collision, I have to go for h4. 3 plus 4 square mod 10. 16 plus 3, 19 mod 10, that equal 9th location. Yes. Assume that 9th location we are having one more key. Again collision. You must have patience if you understand this topic. Collision 5. Then h5 of 30 is equals to 3 plus 5 square mod 10. Right friends, okay. So 5 square means 25 plus 3, 28, 28 mod 10, that equals to 8. Assume that 8th location also collision. Enough. 6 completed friends, okay. Last one now. Interesting now. You try to understand last one. Now if I compute for h6 of 30, that equals to 3 plus 6 square mod 10. What is value friends? 36 plus 3, 39 mod 10. 39 mod 10 means 9th location. Again it moving to 9th location. Very interesting point. Just observe the sequence here. I really like to explain this concept friends, okay. First where we started searching this process? We are starting from third index, right? Third index. Just observe. It is third index. After third index we move to fourth index. So third index to fourth index. Afterwards we are searching in 7th index. 7th index. After 7th index, second index. Second index. Then afterwards 9th index. After 9th index, next we are searching 8th index. Clear friends? Remaining how many locations are empty? Just here 1, 2, 3, 4 and then 5. 1, 2, 3, 4, 5. 5 locations are empty. But if I continue this process, what is happening now? h6 of 30 is mapped into whom? 9th location again. Means from 8 it is mapped into 9. From 9 it will go to next location 2. From 2 it will go to 7. From 7 it will go to 4. From 4 it will go to 3. Again 3 to 4, 4 to 7, 7 to 2, 2 to 8, 2 to 9, 9 to 8. It means that even if you repeat number of times, your search is allowed to search only in these particular indexes. But even though hash table contain empty locations here, it will not allow you to search in those locations. It means that if a hash table size is m, it will search only at most m plus 1 by 2 locations, at most m plus 1 by 2 locations only. For example, here hash table size is 10, so that is 10 plus 1 by 2, okay, and a seal or full, whatever it may be. So 10 plus 1 by 2, that is 11 by 2. 11 by 2 means approximately 5.5. How many keys it is searching? 1, 2, 3, 4, 5, 6. So at most, if you round up this one, 6 location only it is mapping. That is a drawback of quadratic probing. So even though there are some empty locations are there, your search will not allow into that locations. So that is a drawback of quadratic probing. This is called secondary clustering problem. This secondary clustering problem can be resolved by using double hashing. Okay, double hashing. In double hashing, they will provide 2 hash functions. By using those 2 hash functions, we can overcome these problems, friends. Okay. Whereas separate chaining means, suppose if any collision occurs at the particular place, then those nodes are stored in the form of linked list. That is called separate chaining concept. Okay. So these concepts are clear. We'll solve 1 or 2 problems. We'll get more clarity. If it is clear, could you please type CL in the chat box? Clear, right? Yeah, come back to this question. I want to solve very quickly without wasting your time, friends. Okay. So in this problem, they provided key values. They are asking which of the following statements are true. If you observe, what is a hash function for this problem? Hash function is 10. If your hash function is 10, you can focus only unit digit 2, 4, 1, 9, 9, 1, 3 and then 9. It means that these 3 elements, okay, these 3 are having unit digit is 9. When you apply modulus 10, you will get unit digit is 9. Therefore, those 3 are hashing to same location, and then here unit digit is 2, that's only unit digit is 2. Whereas here unit digit is 1, here it is 1, that's these 2 are hashing to same locations. That's what they mentioned here. See, 9, 9, 9 hash into same location, which is correct. 1, 1 hash to same location, which is also correct. All elements to hash into same location, no, it is not correct. Each element hash to different location, which is not correct, friends. Okay, so you can expect questions in this way. Next, here there are 10 buckets are available, means 10 slots are available. They are using linear probing to resolve the collisions, and hash function is key mod 10. If the key values are in this way, they are inserting, then what is the location of the key value 142 to be inserted? 142 to be inserted. So if I take this value 43, here they provide h of key is equal to formula key mod 10, key mod 10. So substitute 43 here, friends. Okay, h of 43, it will go to third location, no collision occurs. So h of 165, fifth location, no collision occurs. H of 62, second location, no collision occurs. H of 123, third location, collision occurs. In linear probing, third location collision occurs, you have to go to fourth location. Verify fourth location, any element is there? No, that's a no collision occurs. Okay. Next, H of 142, H of 142 will go to second location, but second location already key element is there here, key element, that's a collision. Then go to third location, but third location also we are having element collision. Then go to fourth location. Fourth location already one element is there, collision. Then go to fifth location. Fifth location. Verify fifth location, any element is there? No. So answer this question is fifth location, but maybe yes, here fifth location element is there. Sorry for the mistake. Fifth location element is there. Then go for sixth location. Yes, there is no element in sixth location. I can say answer is D. D. If you understood, could you please type U in the chat box? Could you please type U in the chat box, please? Yes. So this is the way you need to complete linear probing questions. All questions you can complete like this, friends. Okay. Yes. Here there is one formula introduced in the class notes. There is a load factor formula, friends. Okay. Load factor formula LF is equals to, generally load factor denoted by alpha. Alpha. Alpha is equals to total number of keys, that equal 2000 by hash table size, that equal 25. That equals to 25 means 80. So that is a load factor. Clear, friends? Okay. Load factor generally denoted by alpha. Alpha is equals to total number of keys by and total number of elements. So therefore total number of elements means 2000 and hash table size, that equal 25. 2000 by 25, that equal 80, friends. Okay. That is called load factor. Yes. It is regarding the question about double hashing. See, double hashing. In double hashing, generally we are using double hashing as formula h of x is equals to h1 of x plus I into h2 of x. What is h1 of x? It is called primary hash function. Primary hash function. What about this one? This is secondary hash function. Secondary hash function. What about I? I indicates collision number. Collision number. Clear, friends? Okay. Actually, when do you go for secondary hash function? If the primary hash function occurs collision, then only go for secondary hash function. Okay. First in this problem, see, do you want to try first? I'll give 1 minute time because I'm keep on talking. You are unable to hear my voice continuously, right? Okay. Could you please try by yourself and tell me what is the answer? Try that question, friends. Did anyone complete this problem? Yes, 13. Only 2 students posted answer, means it is required to explain double hashing. Right friends, okay. What I am trying to say, it is a primary hash function, right? h1 of k equal to k mod 23. So therefore, I am taking first h1 of k. h1 of k is equals to k mod 23. K mod 23, right friends, okay. So first here assume that hash table size is 23, m is equal to 23. Then the address written by the probe 1. Probe 1 means they are asking about collision number 1, I value equal to 1, okay. So probe 1 is nothing but I value equal to 1. That is first collision, means they already mentioned that collision occurs. They already mentioned that collision occurs. Whenever collision occurs, it is compulsory you have to find h2 and h1. For the key value k equal to 90. First find k equal to 90 here. h1 of 90 is equals to 90 mod 23. I think it is 69. 69 means 70. 21 is the answer. Alright. Afterwards, you can find h2 of secondary hash function. This is secondary hash function. h2 of 1 plus h2 of k equals to 1 plus k mod 19. K mod 19. Right friends, okay. So where this is equals to 1 plus, what is k they provided? 90. 90 mod 19. It is h2 of 90, which equal to 1 plus 76 means approximately 14, right. 14 plus 1 that equal to 15, right friends. 14 plus 1 that equal to 15. So they verify in this formula, verify am I doing any calculation mistakes or not. If I do any calculation mistake, you can please let me know. H of 90, the key value is 90, h1 of x, h1 of x means h1 of 90, that equal to 21 plus I value equal to 1, because probe number 1 means first collision, 1 into h2 of 90, that equal to 15, okay. Mod m means here 23, here mod m is also required, mod m 23, which is equals to 36 mod 23. So 36 mod 23 means 13 is the answer. What about your answer, friends? Yes, 13 is the answer. Is it clear, this one? Double hashing. If you understood, simply type U in the chat box, friends. Kindly type U in the chat box. If they ask probe 1, you have to find I equal to 1 value, okay. Right. So most of your typing it is 1. These type of questions also they are asking. So just read the question once. I will explain solution for this. Suppose there are n keys they provided, friends, okay. So there are n keys are available, and there are m slots in the hash table. There are m slots. There are two simple uniform hash functions, h1 and h2 are used. Generally we are using one hash function for hashing key values. This time they are using two hash functions. Suppose there is a scheme that is h1 only for odd number of keys they are using and h2 only for even number of keys they are using. Then what is expected number of keys in a slot? Expected number of keys in a slot means expectation is nothing but average number of keys per slot. What is the formula for average? Average is nothing but total number of keys by total number of slots. Total number of slots, correct? Total number of slots. Here total number of slots already provided m slots. Total how many keys are there? N keys they are distributing. See, suppose in these n keys, you can assume that k keys are odd number, okay, or odd number. If k keys are odd number, then how they are hashing? They are hashing by using h1, because H1 for what purpose? Odd number of keys. If k keys are odd number, H1 you are going to apply for these k keys. Remaining n minus k keys. N minus k keys are even numbers. For even number they are using hash function H2. Okay, but finally ultimately they are moving to the hash table only, right? So they are moving to the hash table. So by using H1 they are mapping into the hash table. By using H2 they are mapping into the hash table. Finally how many elements are in the hash table means n elements only. Therefore n elements are the total number of elements and average is equal to n by m. So answer is n by m. So option B is the correct answer. Whether you use one function or two function, number of elements to hash into the hash table remains same only, right? Therefore n by m is the correct answer. Okay, is it clear? Could you please type CL in the chat box? Right, clear, right? Yeah. Someone is asking, sir, deletion is difficult in linear probing. What is the reason they are asking? Let me explain that reason why it is difficult in linear probing. Why difficult linear probing the deletion means? Suppose imagine you are a database administrator, you are hashing key values into the hash table by using a particular hash function. Assume that is a database. So we are having index and then key elements. Suppose index are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, where your hash function is h of x is equals to x mod 10. X mod 10. You are having key elements here 10, 20, 30, 40, 50, 60, 70, 80. So here you are using hash function that is h of x. When you take 10, 10 mod 10 means it will move to the 0th location. 20 mod 10, 20 mod 10 also move into the 0th location, but you are applying linear probing. Linear probing, if 0th location key is available, you have to go to first location. 30 also hash into 0th location, collision occurs, that is why second location. Like that if I continue, it will fill up the elements like this. 80, 90 something, we are going to store the key values. After a few days, you are planning to remove one database record from the hash table. Suppose you want to remove 40, then you are removing 40 and you left that company, you are not there in that company. Okay, now this 40 key is empty, 40 key is empty. Clear friends? Okay, you left that company, new database administrator joined in that company. Now he want to search a key 50, he want to search a key 50. Then how he is going to search? He will take h of 50, that equal 50 mod 10. 50 mod 10 means 0th location, right? So you will go to 0th location, but 50 is not available. According to linear probing, next location 50 is not available, next location not available. Then he found empty slot. According to linear probing, whenever you find an empty slot, you need to insert the key, right? Then you are again inserting 50 here, but 50 already there in the table, means you are falling under illusion that the key is not available, correct? But key already available here, right? It is creating problem. So therefore, in linear probing or in quadratic probing, in double hashing, in any technique, once you perform deletion, again you have to rehash the complete key elements. Then only searching is easy for next time. Otherwise, you may get wrong illusion that this element is not in the hash table. Okay. So therefore, after deleting 40, again you have to rehash all these elements. That's why deletion is not easy in linear probing, quadratic probing, double hashing. Whereas in separate chaining, it is not like that. In separate chaining, every node is connected with the help of linked list. With the help of linked list. So here deletion is so easy, because if you want to delete this node, simply you can change the link pointer. That's enough. So in separate chaining, deletion is easy. Remaining techniques deletion is very difficult. Clear? Is it clear? Muhammad Abdul? Yes. Correct. That's why deletion is easy in separate chaining. Yeah. Right. Thank you. Now look at this question. They already asked this, right? What is the advantage? An advantage of chain hash table over the open addressing mechanism. Worst case complexity of such operation is less. No, it is not like that. If every element is hashed in the same location, linked list move will take up to length n. That's a searching is not easy. That's why it is not correct answer. Okay. So it is not correct. Space is used less. No, in fact, space is used more because every key we are adding extra what we call pointer to link the next node. So pointer also occupies some space, right? Along with the key, we are having space for pointers also for pointing next node. That's a space is that's not correct. Deletion is easier, yes, because previous node link is pointing to the next node of the deleted node. That's all. That's why answer is C. These are separate chaining concepts. So linear probing, friends, we already discussed linear probing, okay, therefore I don't want to discuss again. It is also linear probing. Now, consider the hash function that distributes the keys uniformly, that hash table having size 20. After hashing, how many keys they are asking? This question, many of you are getting confusion. That's why I am planning to discuss now. After hashing, how many keys will the probability that any new key hashed to collide with an existing key exceeds 0.5? Right, friends? Okay. So actually, what is the meaning of this statement? You also try along with me. Suppose consider there is a hash table of size 10. Here there are some locations where keys are filled, x1, let it be x2 and then x3. Means out of 10 locations, 3 locations are filled. Now if I ask the question, what is the probability new key insertion will create collision? It means that new key insertion will create collision means total actually how many slots are there, friends? How many slots? 1, 2, 3, total 10 slots are there. Out of 10 slots, how many slots are filled here? 3 slots are filled. I want to create a collision. To create a collision, this new key must go to any one of the occupied cell. Correct? If this new key, if hash into any one of the occupied cell, then only collision will occur. How many cells are occupied here? 3 cells or 3 slots are occupied. That's why favorable slots for me to create a collision is 3 by 10. It means that probability of occurrence of collision formula is number of filled slots by total number of slots. Clear, friends? Total number of slots. In this question they are asking the hash table size is 20. Therefore, total number of slots are 20. They are asking how many number of filled slots are required. Number of filled slots. The probability of hashing collision is equal to 0.5. 0.5. So, therefore, it is 0.5. Now, take cross multiplication 20 into 0.5, that equals to 10. Number of filled slots. Now, the last line which I am going to explain is important. If 10 slots are already full, okay, 10 slots are already full with the case, in that case probability of occurrence of collision is 0.5. Clear friends, okay? Means in the hash table 10 slots are already occupied, then probability of occurrence of collision is 0.5. But what did they mention in the question? Probability of occurrence of collision exceeds 0.5. Exceeds 0.5. Exceeds 0.5 means up to 10 slots it is giving 0.5. Therefore, in the question they mentions here, after hashing 10 keys. Now read this one. Up to 10 keys, what is the probability of occurrence of collision? 0.5. Clear? Up to 10 keys, probability of occurrence of collision is 0.5. But after 10 keys, definitely probability of occurrence of collision exceeds 0.5. Therefore, answer is 10. Is it clear? Can you type CL in the chat box if it is clear? Right. It is linear probing concept, so I am not discussing linear probing again. This is also interesting question. How many different insertion sequence of the possible q-values using same hash function on linear probing? This explanation already given in the PYQ book. Please go through it. You will get answer is 30. It is same as the question which I explained binary search tree concept, friends. Okay. This question is interesting. Okay. Just read this question and answer this question. Yes. Now look at this question, friends. Consider hash table with 100 slots. Collisions are resolved by using chaining. Collisions are resolved by using chaining. Assume that there are 100 slots are available. Index and then keys. So there are 100 slots are available. Assuming a simple uniform hashing, what is the probability that first 3 slots are unfilled after first 3 insertions? First 3 slots are unfilled after first 3 insertions. For example, first 3 slots if I consider like 0, 1, 2, these are first 3 slots. Remaining we are having 3, 4, 5 up to so on 99, because hash table contains total 100 slots, right friends. Okay. Now if you take first insertion, while taking first insertion these 3 slots must be unfilled. Okay, unfilled means you have to block these 3 slots, clear friends. Okay. Now they are asking what is the probability that the first 3 slots are unfilled after first 3 insertion. Now I am taking first insertion, after second insertion, after third insertion. In first insertion, how many of them are favorable now? 97 plus are favorable out of 100. Because I want to block these 3 slots, therefore remaining are 97 slots are there. 97 slots. 97 are empty, 97 are favorable to me to hash that value. Therefore, first insertion probability is 97 out of 100 slots. Right friends, okay. Now first insertion is over. Suppose first insertion is inserted at 5th index. Assume that it is x1, 5th index. Tell me what type of collision resolving technique they are using? They are using chaining technique. Chaining technique allowing to store more than one key for the slot. Okay. Next, second insertion. Second insertion also should not go to any one of these 3 locations. Then how many of them are favorable again? 97 slots are favorable, because second key can also go to the same location of x1, same location of x1. Therefore, again 97 locations are favorable out of 100. Next, third one, third insertion, again first 3 slots are blocked, third insertion also may go to the same place also, right. Therefore, again 97 slots are favorable to us, therefore 97 out of 100. But these are independent events, therefore we are applying multiplication symbol among them. So, therefore, answer is option A is the correct answer. Okay. Do you agree? If you agree, simply type AG in the chat box. Type AG in the chat box, friends. Right. Next one. Which one of the following hash function of an integers will distribute keys most uniformly over 10 buckets numbered 0 to 9, I ranging from 0 to 20. Can you answer this question, friends? Could you please answer? Usually my teaching methodology is very slow, and I have some ethics. While I am maintaining whiteboard, I have to write every point very neatly and teach slowly, so that even what we call average student also can understand. That is basic aim of my objective. Like, as a teacher, I want to make the student to understand every concept clearly. Means even average student also should understand my way of communication. But when it comes to revision classes, revision class I need to complete very quickly. So during that process, I may not write every point on the board, and I may not maintain board properly also. Okay. So obviously these are against to teaching ethics, but revision class is nothing but looking like that only. I am communicating very fast. I don't know how many of you are understanding. By chance, if you are not understanding, please excuse me for this, because revision class are looking like this only. But in regular classes, I will try my level best to make you understand. Okay, because then only my self satisfaction is like I can say, as a teacher it is good for me if everybody understand. But I don't know how many of you understand the revision classes. I will try my level best, friends. Okay. P, right? Okay. Just observe, friends. Here hash table contains, and buckets are numbered from 0 to 9. Assume that there is a hash table having buckets numbered from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. They are called index values. They are called index values and key values, correct? Now suppose if I take any value and if I perform square mod 10, then unit digit. Why I am talking about unit digit? Because when you are applying modulus with 10, then definitely unit digits are either 0, 1, 2, 3 up to so 9 only, right? Okay. Then if you perform I square, for example, if you take 0 square mod 10, that equal to 0. So what are the possible combination? Means 0 will come, 1 square mod 10, 1 will come, 2 square mod 10, that equals to 4 will come, but 2 never will come, right? Okay. So we cannot get 2 second index, okay. Means something square mod 10 means second index is not possible. Clear, friends? Similarly, third index also not possible. Second index not possible, third index is not possible. But fourth index is possible if I equal to 2. Suppose if I equal to 2, h of 2 equals to 2 square mod 10, 4 mod 10, that equals to fourth index is possible. Fifth index also possible if I equal to 5. 5 square mod 10, that equal to 25 mod 10, that equal to 5. So sixth index is possible? Yes. Sixth index also possible if I equal to 6. Means there are some particular index are never exist, right? Second index, third index, even I think seventh index also not possible, correct? Seventh index not possible. Therefore, it is not possible to hash second, third, and seventh location. That's why it is not called uniform hashing. uniform hashing is means without bias you have to hash to the hash table, therefore it is not providing uniformly, right friends. Okay. Now if I take 11 I square mod 10, we can also rewrite it as 11 mod 10 star I square mod 10, 11 mod 10 star I square mod 10. What is 11 mod 10 friends? That equals to 1. 11 mod 10 is 1. 1 into I square mod 10. Again we will get I square mod 10 only. Clear? We will get I square mod 10. Therefore, this option C is same as option A. That's why it is not correct, because certain values we cannot hash. Second index, third index, seventh index is not possible to hash. Okay. Of course, remaining index also not, some index other may be not possible. Now look at this one, 12 into I mod 10. We can write it as 12 mod 10 star I mod 10. Whatever 12 mod 10 friends, 12 mod 10 means 2, I mod 10 that equals to I mod 10 only we can write, right. It is nothing but 2 into something. 2 into something means you will get only even indexes. 2 into something means always even indexes. So it is hash into only even indexes. Even indexes. But here second, third, seventh are not hashed by any key values. Clear? They are indexes. Clear friends. Okay. Therefore, who is hashing uniformly means you take any key value here. So I cube mod 10, it is hashing to uniformly 0, 1, 2, 3 up to so on 9. Therefore, option B is the correct answer. Okay. What do you say friends? If it is yes, can you type yes in the chat box? Just S letter, that's enough. Right. Okay. So these are called questions based on dynamic hashing also. This question will take more time because I want to convert into binary numbers. Please see the PYQ question friends. Okay. The dynamic hashing question asked in the recent year papers, you please go through this kind of problems also. It is simple process only, you can go through PYQ book. Yeah. Can you try this question also? I am expecting this type of question this year, especially for DA students. I am expecting this type of questions. Okay. For DA students, can you focus on this? Read this question. Anybody got answer? Right, I will explain friends. Okay. They are asking what is the probability that bucket number 1 is empty after K insertion. Bucket number 1 is empty after K insertion. It is same as previous problem which we discussed just now, 97 by 100 into 97 by 100 into 97 by 100 model. Same model question only. It is asking 97, get 97, and the previous question asked in the recent year paper. So what is the probability that bucket number 1 is empty after K insertion? Okay. So what we will do, we can consider hash table. You can consider hash table. with index and key values. Like index, like we can say 0, 1, 2, 3, 4, like that we are having hash tables like this. Right friends, okay. Total how many insertions they are performing? K insertions. I am writing insertion number also. Insertion number and a probability of inserting that number. Insertion number and probability. Clear friends, okay. So what is the probability that bucket number 1 is empty after kth insertion? After kth insertion, it means that you have to block this bucket number 1. You have to block bucket number 1. Now we are going to insert elements in the remaining locations. Total how many slots are there? Just observe here. The hash function is such that probability that a key value is hashed to a particular bucket is 1 by n. Hash to particular bucket is 1 by n, right? Then the hash table is initially empty with k distinct key values are to be hashed in the table. Clear friends? But how many slots are there in the hash table? N slots. What type of collision mechanism they are using? External chaining. External chaining means separate chaining they are using. Okay. Now look at this one. What is the probability that the bucket number 1 is empty after k insertion? So if I take insertion number 1, first insertion, this first key should not go to the bucket number 1. Okay. We already blocked bucket number 1. If you block bucket number 1, remaining how many slots are there? N minus 1 slots are there, correct? Remaining n minus 1 slots are there. All n minus 1 slots are favorable to me to hash the first key. Therefore, probability of hashing first key without moving to the first location, is probability is n minus 1 by n. Because actually I want to restrict that key to go to first location. If I restrict that first location, remaining how many locations are there friends? N minus 1 locations. Out of n minus location, I want to select all n minus 1 location, right? Therefore, n minus 1 is favorable. Total number of locations are n. Next, now I am going to insert second key. Second key also will have same number of locations are favorable because it is separate chaining mechanism, right? Therefore, n minus 1 slots are favorable to us out of n, right? And third key insertion, n minus 1 slots are favorable to us out of n. Like that we are continuing up to kth insertion. Kth insertion, n minus of 1 by n. That's all. So therefore, what is the probability that bucket number 1 is empty after k insertion? Yes, k insertions are over, bucket number 1 still empty only. Therefore, these are independent events, you can apply multiplications among them. Apply multiplication symbols, which is equals to n minus 1 is multiplied k times n minus 1 whole to the power of k by n to the power of k. Clear friends? That is a probability of inserting, probability that bucket number 1 is empty after k insertions. Okay. If it is clear, could you please type CL in the chat box? Clear, right friends? Okay. No doubts. I am checking in the laptop. Are you having any questions? So no questions. Next one. What is the probability that no collision has occurred in any of the k insertion? No collision has occurred, they are asking. If no collision has occurred any of the k insertion, so shall I remove this part? Okay. I hope you can understand, right? Okay. Right. So what is the probability that no collision has occurred in any of the k insertion? Any of the k insertion. So we are having index like 0, 1, 2, 3 up to so on n minus 1. What is the probability that no collision occurs in any of the k insertion? Suppose if you take insertion number, first insertion and then second insertion, third insertion, this is called insertion number. Up to so on kth insertion, or let me take it as k minus 1 the insertion, and afterwards I am taking kth insertion. Means what is the probability that there is no collision occurs up to kth insertion? Then for first insertion, all locations are empty, right? All locations are empty. So wherever we want we can insert. Therefore n slots are favorable to us out of n slots. The probability that no collision, occurs, equals to out of n slots, all n slots are favorable for me, therefore n by n, followed by probability that second insertion also not having any collision. Suppose first insertion key is stored into second index, x1 stored into second index, then second insertion should not place into the second index, friends. If it is mapped into second index, obviously collision occurs. Therefore how many of them are favorable for me means n minus 1 locations are favorable out of n locations. Therefore second insertion n minus 1 locations are favorable out of n locations, so that it is not having any collision. Okay. Suppose second key is placed into somewhere else. For example, here second key is placed, means 2 slots already occupied. Then third insertion should not go to second index, should not go to n minus 1 index. Remaining how many indexes are possible? N minus 2 indexes. Therefore n minus 2 indexes favorable out of n. Means out of n location, 2 locations are already filled, remaining n minus 2 locations are empty. If I hash third key to the n minus location, there is no collision occurs. So now there is a relation between insertion number and a numerator. If it is third insertion n minus 2, second insertion n minus 1, like that if it is kth insertion n minus of k minus 1, kth insertion, by denominator remains same only. If it is k minus 1 the insertion, we can say n minus of k minus 2 by n. Clear, friends? Okay. By simplifying this one, numerator value n minus 1 up to so on, denominator value is n into k, therefore n power k. Numerator value you can also write it as npk, k object permutation out of n objects, because the formula for npk we define like this: npk is equals to n factorial by n minus k factorial, right? N minus k factorial, where n factorial we can rewrite it as n into n minus 1 into n minus 2 up to so on n minus k minus 1 into n minus k factorial by n minus k factorial. We can eliminate these two, we will have remaining n into n minus 1 and n minus 2 up to n minus k minus 1, that equals to npk, friends. Okay. Therefore in the short format we can write npk by n to the power of k object permutation out of n objects. The short format only they are giving in the options, that is the reason I am writing in this problem. Okay. Now third question, if you observe third question, what is the probability that first collision occurs at kth insertion? First collision occurs at kth insertion. Have you read the problem? I think no need to go to problem statement, right? What is the probability that the first collision occurs at kth insertion? What is the probability that first collision occurs at kth insertion? So we can do the same process up to k minus 1. Up to k minus 1. No collision occurs. Okay, let me write this one. Probability that collision occurs at first collision occurs at kth insertion, they are asking. The third question, clear, friends, at kth insertion. It means that everything remains same, that equals to first insertion n by n followed by second insertion n minus 1 by n followed by third insertion n minus 2 by n, correct? up to k minus 1 insertion we can continue like this, n minus of k minus 2 by n. Now we enter into kth insertion. At kth insertion, I want collision. Collision means it must map to the location where already filled. Are you getting my point? Kth location I want to get collision. In order to get collision, this key, kth insertion key, must map to any one of the filled location. But by the time you reach kth location, by the time you reach kth insertion, how many locations already filled here? K minus 1 locations already filled. If my kth insertion move to the any one of k minus 1 filled location, then only collision occurs. Therefore, favorable for me is k minus 1 are favorable out of n, because k minus 1 locations already filled or not. Please observe friends, k minus 1 locations already filled. It is kth insertion is mapped into any one of the filled location, then only collision occurs, which is equals to numerator value I can say this time npk minus 1, right, npk minus 1, because earlier if it is n minus of k minus 1 we can say npk, if it is npk minus 1 because n minus of k minus 2, and the denominator we are having n power k, it is multiplied by k minus 1 because we are having k minus 1 here. So, this k minus 1 I written as it is, and remaining numerator part np k minus 1 by n power k. Okay. So, this is the answer for probability that first collision occurs at kth insertion. It is the answer for probability that no collision occurs in any of the k insertions. If you like it, simply type L in the chat box, friends. Okay. Right. Any questions, friends? Let me check chat box once. Yeah, no questions. JVSM you are asking, sir, they only asked for one bucket, why do you want need multiply all 1 to k values? I didn't understand your question, JVSM. Right. So, go back to the PPT. Right. So, with this we successfully completed hashing concept, friends. Okay. JVSM, your question I didn't understand what you are asking. This is what is the probability bucket number 1 is empty after kth insertion, right? Bucket number 1 is empty after kth insertion means bucket number 1 you have to block up to kth insertion. So, that is what I explained. Is it clear, JVSM? Yes, thank you. Which topic I have another 1 hour time? Which topic shall I go? Shall I go with stats or linked list or trees, hashing? Shall we start graphs concept, BFS and DFS? First, let me explain some important topics regarding DFS, depth first search. Depth first search, what are the frequently asked questions in theoretical oriented? What is a data structure to be used in DFS? The data structure to be used in DFS is stack concept. Okay. By using stack, we are applying DFS. And the second point is what are the applications of DFS? We are having applications like finding articulation points, finding strongly connected components, finding topological ordering, right friends, okay, and finding bi-connected components. They are applications which we cover in the next class, okay. That is in algorithm class I will discuss those applications. And what is the time complexity of DFS? DFS is using adjacency list. If any graph is represented in the form of adjacency list, it take theta of V plus C. Adjacency matrix means theta of V square, okay. These are important points you should remember. Let me quickly mention those important points. Expected questions, theoretical questions in DFS. The first one, it is using data structure is called stack data structure. Time complexity is theta of V plus C by using adjacency list, okay, with the help of adjacency list. Right friends, okay. So stack and theta of V plus C, and then applications point of view, as I mentioned, finding articulation points, finding topological ordering, finding strongly connected components, finding bi-connected components. So these are applications of DFS. Then how exactly DFS is working? DFS is taking some timestamps. The timestamps are looking like this: discovery time of node U denoted by D of U, finishing time of node U denoted by F of U, finishing time of node U denoted by F of U. So why these timestamps are important means these are important for classification of edges like back edges, forward edges, cross edges, tree edges. For that purpose these timestamps are important. Clear? So let me explain a simple example. Afterwards I will move to the PYQ questions so that you will get more clarity. Suppose A, B, C, D, E, F, let us consider this example. Apply DFS traversal on node A. In DFS, nodes get visited in deeper direction. Nodes get visited in deeper direction until you encounter a node whose adjacent node already been visited. Okay, it means that, for example, if you start in A, if you start DFS in A, you have to go in deeper direction like this, deeper direction, until you encounter a node whose adjacent node already been visited. Then you can apply backtracking for processing remaining nodes. Okay, so therefore, according to algorithm point of view, suppose if I start timestamps, discovery time of A is equals to 1. After discovering A, either you can discover C or you can discover B. That's why for the given graph, unique DFS is not possible. Okay, either I can discover B or I can discover C. Suppose if I discover B, then discovery time of node B should be greater than this value. For uniformity purpose, I am taking 2. That is discovery time. After discovering B, next I can discover D or I can discover E also. So suppose if I discover E, then I can say discovery time of E is equals to more than its discovery time, this is 3. After 3, I can discover in deeper direction like this. That is discovery time of F is equals to more than this, that is equal to 4. After reaching F, either I can discover G or I can discover D also. Suppose if I discover D, then discovery time of D is equals to 5. Then after discovering D, so F is completed, E is completed, right? The processing A, B, E, F, D. Your DFS is looking like this. DFS starting from A, B, E, F, afterwards D. Now interesting point, listen. We started from A, we are discovering nodes in deeper direction like this, deeper direction, until we reach a node whose adjacent node already discovered earlier. If adjacent node already discovered earlier, then what you have to do? You have to apply backtracking for processing remaining nodes. That's the reason you have to assign finishing label. Finishing time of D is equals to, finishing time of D equals to more than its discovery time, because after discovering you are taking finishing time, right? That's why that equal to 6. The moment if you assign finishing time, it is a time to take backtracking for processing remaining nodes. Therefore, you are taking backtracking. Can I assign finishing label here? No. When do you assign finishing label? If for that node, if all adjacent nodes have already been visited, then only can apply finishing label. But for this node, adjacent nodes still not yet visited, right? That's a first finish them, afterwards come back and take finish time. Okay. Therefore, discovery time of H, it is discovering after finishing D, right? It is 6. Therefore, 6 plus 1 you can consider is 7. Actually, this timestamps depends on the OS. Here for uniformity purpose, algorithm point of view, I am assigning timestamps like this. But if you see PYQ question, these timestamps are not consecutive timestamps. Okay, I will discuss one question also. After H, discovery time of C is equals to H. Right, friends? Okay. After discovery time of C, then we can discover. It means that after D, which node we discovered? H. After H, C. After H, C. Then discovery time of G is equal to more than this, that equal to 9. Now we encounter node whose adjacent node already been visited. Then what we have to do? Apply backtracking for processing remaining nodes. Therefore, can apply backtracking. Finishing time of G is equals to 10. Then apply backtracking like this. Okay. So after C we are discovering G. Now at this point of time, all adjacent nodes are already discovered. That's why apply finishing time. Friends, what I am trying to say, when you apply finishing time, you can apply finishing time only if all adjacent nodes have already been discovered. If all adjacent nodes are already discovered, then apply finishing time, take backtracking. Okay. Now again take backtracking. All adjacent nodes already discovered, assign finishing time, that equals to 12. Then finishing time of F, that equal to 13. Come back to here. Finishing time of E, that equal to 14. Then come back to this place. Finishing time of B, 15. Come back here. Finishing time of A, that equal to 16. Therefore, it is one of the DFS traversals. One of the DFS traversals. I can find so many DFS traversals. For example, if I write whether it is possible or not, just check it once. A, C, H, F, G, E, B, D. I want to verify is it valid or not. So, exam point of view, this kind of analysis is most important. Try to understand, friends. Start from A, C, H, F, G. A, C, H, F, G. Kindly look at here. A, C, H, F, G. A, C, H, F, G. After reaching G, C already having blue colored ink, means already visited. Then what I have to do? I have to apply backtracking. Apply backtracking to F. After F, either I can go for E or I can go for D. Therefore, to whom they are taking after G? They are going to E. Yes, it is correct. G, E. After E, they are taking B. Then they are using D. F, E, B, D. G, F, G, E, B, D. Yes, correct. G, E, B, D. So, therefore, that is valid DFS traversals. Okay, valid DFS. So, this is the way you need to understand the concept of DFS. Suppose if the finishing time, just look at here, if the finishing time is greater than the finishing time of remaining all vertices, if the finishing time of starting vertex greater than the finishing time of remaining all vertices, then we can say that the whole graph is connected. Okay, whole graph is connected. Based on this also we will discuss one important point. Okay, go back to the now quickly tell me the gate question. They are asking which are the following are DFS traversals. Can you answer this question kindly, please? Yes. Most of you giving correct answer only. Try to understand, friends. If you observe A, B, E, G, H, F, I am showing in the form of red color A, B, E, G, H, F, A, B, E, G, H, F. So, A to B, B to E, A, B, E, E to G, G to H, H to F, like this. A, B, E, G, H, F. Yes, it is valid DFS. After reaching F, you are taking backtracking, 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 and then A. Is it clear? So, therefore, A is correct. First one is correct. First one is correct. Now, look at second one. A, B, F. Let me start here. Observe, please, kindly observe. A and then B, afterwards F. A to B, B to F. Now, you tell me, friends, after reaching F, which node I need to visit in deeper direction? So, I have to visit in deeper direction either H or G, correct? Because DFS always traverses nodes in deeper direction only. After F, you have to reach either H or you have to reach G. But to whom they are visiting? They are visiting E. Means in the middle of the process, they are taking backtracking, they are visiting E. It is not allowed in DFS, okay? That's why it is not correct. It is not correct, okay? In the middle of the process, we cannot go back. Next, ABFHG, please excuse me. ABFHG. So, ABFHG means, say, A, afterwards we are taking B, afterwards F, after F H, H to G, G to E. Yes, it is correct. Afterwards it is taking backtracking, backtracking, come back to previous stage. Similarly, AFG, HB, AFG, HBE, which is also correct. Therefore, answer this question is 1, 3, 4. Option D is the correct answer. Okay. Right. In DFS traversal of a graph G with n vertices and k edges are marked as tree edges, then the number of connected components in the G is. For this type of problem, what you will do, you take example, friends. So don't do mathematical proofs. Okay, go for with examples only. Go with examples. For example, I am taking simple example. I am taking. Suppose V1 is a vertex, V2, V3. Let be V4, V5. Clear? Let me take 6, V6. This graph consisting of 6 vertices. I can take simple example only. I can take simple example I can explain, but I want to take multiple graphs. So therefore, you will get more clarity. This is a graph having 6 vertices, 3 edges. 1, 2, 3, 4, 5, 6 vertices, 3 edges. And this graph is having 3 connected components. It is one component, it is second component, this is third component. So it is having 3 connected components. 3 connected components. Clear? Let me draw one more edge, friends, here. Let me draw one more edge. Therefore, 6 vertices and then 4 edges. So that you will get more clarity why I am taking one more edge here. Okay, 4 edges. Now apply DFS traversal. I can explain this question with this by taking simple example also, but I want to explain more concepts here. That's why I am taking this one. Okay. So apply DFS traversal. First I am taking V1. After V1 I am crossing V2. After V2 I am crossing V3. That's all. Means you are taking discovery time of V1 is equal to 1. After discovery time of V2, 2. Discovery time of V3, that equal to 3. After still applying finishing time of V3 is equals to 4. Go back to this place. Because after reaching this node, it is not possible to reach V4, right? That's why I have to go back to previous stage. And then finishing time of V2, 5. Go back to here. Finishing time of V1, 6. Right, friends, okay? Then come to this place. Now again start DFS algorithm here. So discovery time of V4 more than this, that equal to 7, and then process this one. Discovery time of V5 that equal to 8. After finishing time of V5, 9, finishing time of V4 that equals to 10, and finally I can apply discovery time here. So discovery time of V6 11, finishing time of V6 12. That's all friends. Okay. So in this problem, what are the tree edges? Tree edges for undirected graph. Please understand. In this graph, whatever yellow color lines are there, these yellow color lines, these are called back edges. In DFS traversal, please understand, DFS traversal, there are two types of edges are possible in undirected graph. One is called tree edges, another one is called back edges. Okay. So what I am going to explain now, what is tree edge, what is back edge. Tree edge is nothing but, it is for undirected graph I am talking. Okay, it is for undirected graph, not for directed graph. For directed graph we will discuss in algorithm subject. At this point of time I will discuss only undirected graph. So tree edge is nothing but edges present in the graph as well as in DFS tree. Those edges are called tree edges. What are the edges are present in the graph as well as DFS tree? Like these yellow color lines are called tree edges. So tree edges are like V1 to V2, and then V2 to V3, and then V4 to V5. These are called tree edges. Yellow color lines. Okay, I will show in the form of yellow color line, because these are the lines which are available in DFS traversal as well as in the graph. Edges which are present in DFS traversal and the graph, those are called tree edges. Then what about back edges? Back edges means edges which are present in the graph but not in DFS tree. For example, V1 to V3 present in the graph but not in DFS tree, right? Therefore, V1 to V3 is back edge. So for this question I had taken an opportunity to explain back edge, tree edge. Right, now come back to this question. In a DFS traversal of G with n vertices, in this graph how many vertices friends? 6 vertices. So total number of vertices V is equal to n, that equal to 6 vertices. K edges are marked as tree edges. How many tree edges we have? 3. K edges are marked as 3 tree edges. Now they are asking the number of connected components in G. How many connected components are there? How many? It is one component, it is second component, it is third component. Single vertex also component. Therefore, number of connected components are 3. 3 connected components. Means for n is equal to 6, k is equal to 3 components are there. Substitute here friends. If you take n is equal to 6 and k is equal to 3, we will have answer is 3. Any other option is satisfying? No, right? Therefore, option D is correct. Actually, for answering this question, this much explanation is not required for you. You can directly take simple example. Why you want to go for multiple diagrams? You can directly go for only one diagram. Okay. Suppose for example, if I take 3 vertices and 3 edges graph, you can directly take V1, V2 and then V3. Directly can take only one graph and apply DFS traversal. If you apply DFS traversal, it is first edge and second edge. They are known as tree edges. Therefore, k is equal to how many tree edges? 2 edges are tree edges. And n is equal to how many vertices? 3 vertices. How many components are there here? Only one component is there. Therefore, n minus k. It is very easy to answer this question, but I am taking this opportunity to explain multiple concepts in the same problem. I hope you like it, right? Yes. Thank you for your support. Fine. Yes, look at this question. Can you try this question, friends? Okay. Can you try this question? 2 components, right? So options are not visible. No problem, you don't worry about options. Okay, yeah, right. 2 connected components, for example, see here discovery time of P is equals to discovery time of P equal to 5. Please excuse me. Discovery time of P equal to 5 means what you will do, just arrange the increasing order, friends. Okay, you just arrange the increasing order. First they are discovering P, discovery time of P is less than or equal to, after discovering P, to whom they are discovering? They are discovering Q, means after timestamp 5 units, next timestamp is 6, means after P only they are discovering Q, right? So that is discovering Q. After discovering Q, next timestamps after 6, next one is 10, it means they are finishing Q. Without reaching or they are finishing Q. Finishing Q. It means you can imagine there is a vertex P, there is a vertex Q, there is a connection between these two. First they discovered P with a timestamp is equal to 5. Afterwards they discovered Q with the timestamp is equals to 6. Then it is not possible to reach R. That is the reason they are finishing here itself only. The finishing time of Q is equals to how much, friends? 10. After 10, then going back, they are finishing P also. Finishing time of P. That is equals to 12. After 12 units time, then they are spending time for discovering R. That is equals to 14. 14. After they are finishing, that equal to 15. No, 18. It means that there are 2 connected components are there. One is P comma Q connected, P comma Q connected. Another one is R is separate component. Okay. So in the options they are providing options like this. There is only one connected component, no. There are 2 connected components, yes. P and R connected, no. There are 2 connected components, P and Q and R connected, no. Therefore, answer this question is option. There are 2 connected components where P and Q are connected. Clear, friends? Okay. So this is the way you need to understand connected components concept. So same model questions you can practice about DFS. These questions already discussed actually last year papers. It's not required. It is actually BFS. Yeah, I'll explain BFS also now. But before that, look at this question. Have you practiced this question, friends? In DFS, can you check this question? Could you please check this question? Post your answer in the chat box. I think most of you already tried this question, right? 19. Good. Right, most of you are providing answers. So the best idea to traverse a tree is, they are asking maximum depth of recursive call. Then where you have to start? Suppose if you start recursion at middle, DFS traversal splitting the tree into 3 parts, left part, middle part, right part. You will not get maximum depth. You will get maximum depth of recursive call only if you are starting at corner node, right? So therefore, you can start like this. It is a first node. Okay, I can say A, B, C, D, E, F, G, H, I. Like this. Okay. So you can start from corner node, you will get maximum depth, friends. Maximum depth. Total actually we are having 21 nodes. 21 nodes. Therefore, here you are moving to K and coming back to this place. Coming back to this place. Here you are moving to P and coming back to this place. Means these 2 edges we cannot count in the recursion, because tree is growing in deeper direction. You are going back to K and coming back, and you are going to going to P and coming back. That's why those two edges we cannot count. So therefore total we are having 21 vertices, then definitely maximum depth of the recursive call is 19 is the answer. Okay. If you want I can explain, just observe. So A to B, B to C, C to D, D to E, E to F, F to G, G to H, H to I and I to J. So it is tree is growing up to linearly like this, okay, linearly from where to where, A to J it is growing linearly. So quick explanation, starting from A we need to consider A, B, C, D, E, F, G, H, I and then J, correct? Up to J it is working like that. Afterwards from J they are visiting K and then taking backtracking. It means from J they are taking K, apply backtracking. Now we will continue from J only. If I continue from J, L, M, N, O like that, L, M, N, O, L, M, N, right friends, okay, N afterwards O. After taking O again it is taking P and apply backtracking. Backtracking, continue Q, R, S, T, U. Q, R, S, T and then U. That's all, S, T, U. Therefore, maximum depth of recursive call means you can consider like this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. That is the maximum depth of recursive call. Okay. So therefore, answer is 19 is a correct answer. You can also try for minimum depth to cover all the vertices. Minimum depth is you can find from the textbook also I provide this question, minimum depth of the recursive call. Okay. Yes, min is 8, correct. That's all about BFS, DFS algorithm friends. Okay. Once DFS is completed, next one is BFS algorithm. Okay. I will explain simple example for BFS algorithm. What are the points they will ask in BFS? First, the data structure to be used to implement BFS is called Q data structure. Q data structure. It is also implemented by using adjacency list whose time complex is theta of V plus E. These are key points. Okay. And the next one, why BFS useful find? So it is useful for finding shortest path distance, from source to destination from source to destination in an unweighted graph. This point is important point friends. Okay. For weighted graph we have so many shortest path algorithms. For weighted graph we are having die-Kust algorithm, Bellman-Ford algorithm, multi-stage graph, traveling salesperson, Floyd-Warshall's algorithm. But for unweighted graph we have only one algorithm, that is BFS algorithm. Okay. It is running linear time. One time in the gate they asked the question, die-Kust algorithm is implemented by using die-Kust algorithm implemented unweighted graph so that it runs in linear time. It means that it runs in linear time unweighted graph means that is called BFS only. Okay. So performing BFS, please understand that point. Okay. Next, how exactly BFS is working? Very simple. Suppose if I start BFS algorithm on M, if I start BFS algorithm is M, please observe friends. First I will explain the process. Initially, assume that we are taking vertices here. What are vertices we are having? M, N, O, P, Q, R. M and O, P, Q are the vertices. Initially, I am giving color for each and every vertices according to Corman textbook I am explaining, but I will explain shortcut method also. Okay. First, let me explain Corman textbook point of view. Okay. Suppose initially we are having each and every vertex having white color. Okay. We can make it as white color, some color, whatever it may be, white or black, what it may be. Initially we are having white color. Okay. And count they are having, initially all vertices are having count is equals to, except source vertex remaining all count values we do not know, we can keep it empty like this. Okay. You can keep it empty now. See, so when you are starting BFS algorithm vertex M, you can change this color as gray. You can change this color as gray, and NQ into the Q, NQ into Q. So therefore, we are having Q data structure and NQ into the Q. After NQing, identify all adjacent nodes of M. Okay, identify all adjacent nodes of M. Okay. Before that, what you have to do? First, you have to dequeue that node from the Q and then identify adjacent nodes, because every time we are taking element from only Q, Clear, friends? Okay. So therefore, dequeue this node from the Q. Dequeue this node from the Q. After dequeuing, you can identify all adjacent nodes of M. Who are the adjacent nodes of M? Just observe. Adjacent nodes of M, N, O, R. They are adjacent nodes. If you identify adjacent nodes, now verify their color. What is the color? Initially, what is the color we provided? White color. White color. If the adjacent nodes of M are having white color, mark them as a gray color. Okay. So mark them as gray color. Afterwards, you can NQ into the Q. Clear? We can NQ into the Q. So therefore, who are the adjacent nodes? M adjacent node is N, Q, R. So therefore, M adjacent node is N, Q, R, N, and then Q, R. Mark it as gray color. So mark it as gray color, mark it as gray color. Then source vertex count is equal to 0. Since we explode N, we explode Q, we explode R, all from M only. Therefore, N count is equal to M count plus 1. M count is 0, 0 plus 1, 1. And Q count is 0 plus 1, 1. R count is 0 plus 1, 1. Do you know what is the meaning of this one? I can reach R from the source M with the count with the value is equal to 1. Means it is 1 unit distance from M. Clear? Q is also 1 unit distance from this one. Okay. If you want, you can trace out predecessor also. Predecessor. So how we are reaching? We are reaching from M only. Is it clear, friends? Afterwards, after taking all adjacent nodes, mark it as black color. Black color means this node already exploded its children. That's all. Mark it as black color means this node already exploded its children. Right, friends? Okay. Therefore, your BFS first node is M. Right. Now, next node in the Q. Who is the next node? First explore. You are making gray color for N, gray color for Q, gray color for R. You have to NQ into the Q. So N, Q, R. They are adjacent nodes. Now again perform DQ element, that is N. Identify adjacent nodes of N. Who are the adjacent nodes of N? Adjacent nodes of N are O and then Q, M. Adjacent nodes of N, O, Q, M. But M already having black color. Okay. So identify the adjacent nodes which are having white color. Who are the having white color? N adjacent node is O, N adjacent node is Q. So Q is already having green color, right? O is not having, therefore mark it as gray color. And from where we are exploring? From N we are exploring. Therefore, N count plus 1. N count is equal to 1, 1 plus 1 that equal to 2. Do you know what is the meaning of this one? We are exploring O or we are reaching O from the source M. We are reaching O from the source M with the distance is 2 units. Okay. So therefore, N adjacent nodes are M, already marked as it is not having white color. Q, it is also not having white color. Only O is having white color. That's why I made it as gray color. O. That's only one adjacent vertex is there. Okay. Now, after making gray color, then you can NQ that node into Q. You can NQ that node into Q. Right, friends. Okay. Then N explode all adjacent nodes. Then what is the color you have to change? You have to change color as black. Black. Okay. So therefore, next node is N completed. Next DQ DQ means delete Q, identify adjacent nodes of Q. Who are the adjacent nodes of Q? M, N, O, P, M and O, P. But M already having, M is not having white color, N is not having white color, Q is not having white color. Okay. What about P? P is having white color. That's why I mark it as visited. That is gray color. Okay. After making gray color, excuse me, from where we are exploring? We are exploring from Q. Therefore, from Q I am exploring P. From Q I am exploring P. Q count is equal to 1, 1 plus 1 that equal to 2. Do you know what is the meaning of the statement? I can reach P from M with the distance is 2 via Q. Right friends, okay. So, all adjacent nodes are explored. Therefore, you can DQ, then you can write then BFS here. Right friends, okay. Then but you have to take P inside the Q. Next node is R, DQ that node. Identify adjacent nodes of R. Adjacent nodes of R, look at here. What are the adjacent nodes of R? M. But M already having white, M is not having white color. If it is having white color, then only you can change the color. Next, afterwards, R is completed. Next one is O. Identify adjacent nodes of O. Adjacent nodes of O are NQP. But NQP already having, not having white color. They are not having white color. So, therefore, what you have to do, simply write here O. Afterwards, next one is P. Actually, we need to change their colors also. Okay, once you are writing M and Q R O, so Q becomes black color and R also becomes black color, O also becomes black color. Next node is P. P adjacent nodes. Who are the adjacent nodes? O and Q. They are adjacent nodes. So, adjacent nodes already having, not having white color, not having white color. So, therefore, mark it as black color. That's all. This is one of the BFS traversal, MNQROP. Actually, there are so many BFS traversals are possible. Now, I am going to explain how to make this question easy in your exam point of view. Just observe friends, okay. Exam point of view, how quickly you can answer? You can apply this trick. Simply take Q. Kindly look at here friends. Simply put elements in the Q. Right. Identify adjacent nodes of M. Who are the adjacent nodes of M? Adjacent nodes of M is N, Q, R. Means next 3 locations, only those 3 elements are there, N, Q, R. Whatever order it may be, but next 3 locations must be N, Q, R only. So, N is okay. How you will get O? Is it possible? No. Therefore, we are not getting adjacent nodes of M properly. That's why it is not a valid BFS. Okay. Now look at this one. First node is N. Identify the adjacent nodes of N. Who are the adjacent nodes of N? Adjacent nodes of N is O, Q, M. OQM or MQO. So, MQO, these are the only 3 elements in the next 3 locations. Q is okay, M is okay, but how will you get P? Is it possible to get P? No, because according to this one, N adjacent nodes are MQO. I am expecting only MQO, but here M is okay, Q is okay, P is not possible, ignore it. Next, if I consider this one, who are the adjacent nodes of Q? Adjacent nodes of Q is M, N, O, P, M, N, O, P. Whatever order it may be, but those 4 elements must be there in the next 4 locations, M, N, O, P. M is okay, N is okay, how will you get R? R is not possible. I am expecting adjacent nodes for Q is M, N, O, P, but here M, N okay, but R is not possible. Ignore this. The gate question, after evaluating 3 questions, obviously 4th one is correct answer only. So, if you want you can try, but in the exam don't try, your marks will not increase. Okay. So, if you take P adjacent nodes, who are the adjacent nodes of P? Q and then O. That is why they are having O and Q, whatever order it may be. So, P completed. Then who are the adjacent nodes of O? Adjacent nodes of O, M, N is there, Q, P, N, Q, P. In N, Q, P, already Q is there, P is there. That is why they are exploring N only. They are exploring N only. Therefore, DQ this node completed. Next, who are the adjacent nodes of Q? Adjacent nodes of Q, M, N, O, P. In M, N, O, P, P completed, O completed, N completed. Only M we need to explore. That is why they are exploring M. So, afterwards, N adjacent nodes. N adjacent node is M, Q, O. M already explored, Q already explored, O already explored. That is why no need to explore any other node. Next, M adjacent nodes. M adjacent node is N, Q, N, Q, R. N already available, R is already available, Q already available, R is not there, therefore I am excluding R. Therefore, answer is option D.